Hello, everybody. Welcome back. It is day 4, our final day of Certified Ethical Hacker Technical Skills in 2 weeks with Dean Bushmiller. And as usual, before we begin, I'll point out some of those widgets that you may find useful. The resources widget is where you can download the slides and access the links. And the Q&A widget is where you can ask your questions that you would like Dean to answer directly. We do have a group chat feature available. You're highly encouraged to use that group chat. And just remember, your messages will be shared with the entire group. If you have any technical trouble today, first refresh your browser. If that doesn't fix the problem, please let me know in the chat box or the Q&A, and I'll be happy to help you with that. And I do have to warn you, for those who are subject to regulated status, that the chat feature should not be used and that the audience may include customers, vendors, or competitors of you or your employer. And if you choose to take advantage of these interactive features in this training, and we really hope that you will, you are responsible for any information that you choose to share. And now I will hand it over to our instructor, Dean Bushmiller. The floor is yours.
Thank you. We'll be cruising at 497 feet because that's the altitude of Austin, Texas. I'm glad you're back. I'm glad you made it back. I'm glad you're here. I also want to thank all the people that worked really hard to tell me that the lab was working. So I got a bunch of messages this morning. The lab is working. So if your lab isn't working, go back to the original details of the GitHub, and it should take care of that particular issue for you. So let's talk a little agenda here just for the day. So I want to sneak in. I got just enough time to sneak in the malware section of the course. I just want to let you know that. I got just over 10 minutes in there. And then it's going to be web server, web applications, and databases all day long. So I just want to let you know that right away. So that's the first thing. So that's where we're going today. And before we do that, jump into Mentimeter. I'm going to need you to come on over here, and I'll get out of the way of the QR code if you're doing it on your phone. Will you be responding to our email even after today? CT, yes, I will. It is very important for you to understand that I am here for you after this class is over with. Now, I teach 9 different classes. So the important thing for you to do in order to get me to respond quickly is to set the tone in the subject. So if you type in CEH 4-day question, you got it made. You're going to float to the top of my list of things to do. That's like 4th in my list is all my different classes. So if you put in CEH 4-day in the subject line, I'm going to see that right away. I'm going to know that you are waiting for me. I'm blocking you from doing your next activity in there. I'll be pretty brutal about it. If you can look it up and find it, and you didn't look it up and find it and show me your work, then I'm going to say you need to look it up, and I'll direct you. Either it's going to be the website or the GitHub or the lab, and then that's all you're going to get from me. But if you do the work and you show me that you're doing the work, I'm in it to win it with you. I want you to go ahead and do what you need to do. I don't give consulting advice. That's the only thing that I don't do when people ask me about how to start consulting practices. I just don't talk about that. You get a little flavor of that in class. That's my secret sauce. So yes, I'm happy to do that. And remember, one of my metrics, I don't know if I said this to you all on the first day, one of my metrics is the number of emails that I respond to students on a regular basis. So that's my metric. That's not an O'Reilly thing. Okay, so now let's talk about questions. By the way, this is one of my favorite rides right here. This ride is only stops in emergencies, and crying is not an emergency. So I love that. So you can ask me anything here. I'm going to give about 90 seconds. If I don't see anything in 60 seconds, we're going to move on from here. So that's the thing about questions. I'm going to post a couple of things into the attendee chat for everybody. The first one's going to be this form to fill out. If you have not filled out this form, do so today if you want my quizzer. And that is going to be the second thing that we're going to talk about. I'm going to give you just a little tiny tour of this thing right here. You will not get an account for this until probably Wednesday midday, late in the day. That gives all the people that are watching this in a recording, because it's a 4-day class and some people catch up later on. I give everybody that extra day to do it. The links that are in the session chat are live after the class. The links and the things that are inside of the Mentimeter are not. The links that are inside of the mind maps, you can always do them and always download those. If for some reason you forget the password, it goes out of your brain and you need it later on, what you have to say to me is that you were in class. And if I feel like you weren't in class, I'm going to say, refer to the recording because people try and scam me out of that password all the time. But to that end, just in the recording today, you can remember at the very beginning of day 4, Dean said there was a recording. I'm sorry, that's the wrong one. At the very beginning of day 4, Dean said he put the password into the attendee chat so I can see it. And there it is. You can look in the attendee chat so that you can see that password right there. And that way you don't have to worry about searching through the whole recording because it's on day 4 and you'll always have those recordings. Let's see. I don't see any questions coming in. So I want to talk about some other kind of cool things today. So I want to get at it today. So next thing that I'm going to talk about here is the VMLT Quizzer Tour. So that link that I put is this. It's called the pink form. And remember, you can use all of those pseudonyms if you want to. If for some reason today you over this past 4 days you did a lot of doing and you want more exam theory and more exam practice, you can get it in one of 2 ways. You can go to the CEH recordings that I've put up in the O'Reilly library, and you can watch it asynchronously. That's called what I call domain 0. It's getting set up. If you want to do interactive Q&A after you watch that video, there is a 2-day CEH course coming up. It's like the first week or the second week of April. That class is much more geared toward the exam processing kind of stuff. We did a lot of, this is where you do your labs, this is how you do your labs, this is how you get set up, those kinds of things, much more on the doing aspect of the course. So what this will get you, it will get you an account on my system. Now, I want to be clear about whatever you give me. You'll get your account login is what you'll get from me. You'll get, if I'm doing another course on the same thing. So if you signed up for a CEH course, I'll send you messages about O'Reilly courses only. I won't try and advertise to you for my other courses. That's not a part of what we're doing here. So that will be the one advertisement that you get from me. If your account is about to expire, you'll get expiration notices from me. Don't panic though. If you had an account and you lose the account because you say, oh, I'm going to put CEH on the back burner, I'm going to go do this thing or that thing or something like that. But I want to do this and I lost my Quizzer access, just send me an email. That's all you have to do. And remember, my email is the same every single time. It's 1@vmlt.com. I put that into the attendee chat also. Now, for this Quizzer, it's very simple. You can look at the logistics if you want to, but here's the way it works. You do the introduction for the introduction quiz. When you click on this link right here, what that will do is that will lead you into the introduction quiz. You must get 100% on the introduction quiz. If you miss anything out of the introduction quiz, go back and study immediately. Don't do anything else. Don't try to take other quizzes and say, well, I'll come back to that. Stick with the basics and the beginnings. And if you don't have those terms down and you don't have those functions down, do not waste your time going on. So get 100%. If you go through each one of these sections that I have here, each one of these is a set of quizzes, and you get a 95% on each one of these. Of the 300 or so people that have taken this particular version of this quiz over the past 2 years, The ones that got 95%, so far I have not had any fails. Don't be the first one, okay? Don't be the first one. The other bonus that you get out of this, you'll notice that I've only been giving you some of the mind maps. There's a section here on the digital mind maps, and you can go right here, and then you can get every single one of, well, it won't show up just yet. These are hidden right at this second. But you can get every one of the mind maps for the class. So you'll be able to see them. Let's see, yeah, and so I will open those back up. I had to close them down for a little while because of a problem that I was running into with a couple of students. So I'll open that list up. You can go in there and you can click on each one of those mind maps and you can see them right on the website. So that's the tour. That's all there is to it. It's not very fancy. It's, can you get a 95% on each one? And that means that you can retake them as many times as you want to. As soon as you find something wrong with the question, tell me. As soon as you find something wrong with yourself where you don't know that thing, whip out a note card, write the topic on the online side, and then you go back to your reading, you go back to your videos, you go back to your labs, and then you reach out to me. So that's the plan in a nutshell. Okay, that takes care of that. That was the 2-minute quiz tour. So we are into the hacking process overview. Before we do that, I want to go over to the mind map and I want to talk about mind map session hijacking tool. I did not talk about it yesterday. I skipped over it. There are 2 tools for this, EtterCap and BetterCap. They are essentially the same thing, and you need to spend 20 minutes on that tool. So I didn't talk about that yesterday. I wanted to point to that. So you can look that up in Kaylee Tools. It'll be there available to you. Okay, malware. Now, a couple of components here. First off, pure exam stuff. You'll see it says for exam only. Types of Trojans, types of viruses. I give you the list of all the different possible types of Trojans and types of viruses that you have to have definitions for. Those definitions, talked about this on the first day, are in your glossary. And if they're not there, they're easily and readily looked up. You should, again, commit each one of those to a note card and then get your definition on the other side. I talk about the note carding process in the 2-day course or in the videos, whichever one you want. So you have to have those types of Trojans and types of viruses, and you have to be able to compare and contrast those. I don't want to waste your time in this class doing that because it's just a straight memorization exercise that goes along with this. Now, the other thing that I wanted to talk about was the core terms in this. This is another set of terms that you have to deal with. You have to define viruses, worms, Trojans, and then I give you the components of malware here. This should have been something that you came in with from a lot of other courses, and if you didn't, it's okay because we talk about each one of those components right there. So that's the components of malware. The components of building malware, not really, okay? Any of these tools that you use here are relevant for the exam, but if you try to do them in the real world with any kind of penetration testing that's out there, you will fail. It's as simple as that. When I do testing for antivirus and testing for malware, the important part is that viruses require user interaction. I hope we're all okay with that. Viruses require the end user to click. So what I do in my virus testing that I talk about for my customers is I say, okay, I'm going to send a phishing attack in, and that phishing attack is going to be, it's going to have a link in it. They know they're not supposed to click on links. What I do on my side is I set up a website that says when they click on the link, I start a timer, okay, from the time that they click on the link till the time that they close the browser window. Does that make sense in your mind? Okay. So the minimum time for evil to get in across a browser because they click the link, or for the start of execution of some sort of Trojan or malware, is about 7 seconds. That's the shortest it can be. The longest it can be, which is not sophisticated adversaries that are generating new malware today, is 1 minute. So what I do is I send out my phishing email. How many people click on that? Let's say I send 100 emails and 7 people click, right? I know that the other 93 people are good. How long do the 7 people dwell? I capture that information and I say anybody who is here for more than 7 seconds up to a minute, and I stop the timer at that point. Anytime that they're in that range right there, that represents that you will be compromised by the latest malware and Trojan. So I just look at the time there, I state that very clearly, and I say that's what that represents, because if I can get them to click, that means that they're able to resolve, they're able to get through controls, they're going to a place that they shouldn't be going to, and getting delivered software that they shouldn't. And so that's how I do that calculation. I do not do the steps here because they don't work against modern ERM, antivirus, anti-malware, anti-everything. None of these things work against those, so I just don't do these things. But these steps that you understand for building Trojans, this set of steps here, this 6 steps, is relevant to the exam, the end. So that's all of that. Now what we want to do is we want to restart this whole thing and just talk about the concept here just for a second before we walk away. Today, it's all about getting paid. That's cryptocurrency mining and ransomware. We all know that that's happening. When we talk about the new terms out there, they're very precise. They have nothing to do with the exam. And where this all comes from now, if you're doing this at a scientific level, is what's called CAPEC. I do an entire discussion. There's a 3-hour discussion on threats and vulnerabilities. And in the threats and vulnerabilities, I talk about CAPEC and how that works. That's beyond the scope of this course, but know that that's kind of where you live when you're out in the real world, talking about common attack patterns and enumeration classification. You could say, well, Dean, what about MITRE's attack? I do a 4-hour course on MITRE attack, but in my threats and vulnerabilities 3-hour presentation, I also talk about MITRE attack in a very stripped down way so that you can get the idea of what's going on there. So that's how it gets done in the real world. But we don't want to lose sight of the exam. And I like to be precise about this stuff, but I have to kind of like push that away and say, what does the exam focus on? Which is really rotten thing to say, but it's just the truth of the matter. So if we look at yesterday, we talk about malicious software and what it does. And then when we're out in the rest of the world, they use the word ransomware, they use the word crypto mining, but most of the time they'll talk about viruses, worms, and Trojans. And you have to be able to distinguish between them. But the reality is that real malware today has got all of that stuff all shoved in it. And the exam is centered around those terms. And here's the last thing that I wanted to say. Do not work in this area. But if you do, what you want to do is you want to learn about reverse engineering malware. That's how you do that. If you like debuggers, if you like decompiling software, if you've done that for your life, reverse engineering malware may be for you. For the exam, all you have to do is understand what reverse engineering malware is, which is decompiling software. The tools that you use to do reverse engineering malware, the actual tools that you carry to do that, are illegal in certain jurisdictions. Look up your jurisdiction, look up if you're crossing boundaries and borders. And so what I do when I travel to stop that is I use a separate encrypted drive that actually has push buttons on it. It's called an apricorn, like an acorn, but it's apricorn. And if you key in the password on the little buttons on it a certain number of times wrong, it clears the drive. And so therefore, if I was ever asked by the police in a particular jurisdiction and they were looking at it, I'd say I have to key in the password to do it. And I would key in the wrong password and have it wiped and say, oh, well, wait a minute, I fat fingered it and now I keyed it in, and they open it up and the drive's been wiped. So there's nothing on it. So I always use a separate encrypted drive for that. You can get small ones for $40 or $50 with physical buttons on them, not encrypted, because then they can ask you for your password. But when it's actually encrypted with AES and you use those buttons on it, you win because it protects you. If you've decided to go into doing this process of malware and the timing of it, be sure to wipe the key from the fingerprints to make it harder for someone else to guess. Oh, by the way, AD, that's a good thing. The apricorn, actually, each one of the buttons themselves have this weird texture to them so that you can't see the digits. But by the way, there's 10 digits on there, and I always make mine a 10-digit passcode. So therefore, I've pressed every single button. So I'm right with you, AD. Good idea. Okay, what we're trying to do in all of the malware stuff as penetration testers is increase the chances of insertion. We do that through phishing, social engineering, clickjacking. It is possible to do this, what's called a zero click, but it's very, very rare today. What adversaries are doing is they're compromising legitimate websites out there that are very small websites that do one thing. I have somebody that I work with who is trying to publish his own book. He's trying to get a publisher to work with him. And the way that he does that is he stands up his website, and it's just, it's just a couple of pages on him and a couple of pages on his book. And he goes, well, I don't have to worry about this. Nobody's going to attack me. Nobody cares about me. And I go, that's not what they care about. They want to use your website to get to other people so it looks like a legitimate website. The classic way that this is done for when the website is compromised, once they get a hold of this little tiny website here, what they say is they take out advertisements on Google keywords that say a coupon for Office. They actually buy coupons that will work for Office, real coupons. So if Office is $300 or euros, they'll give you a 50% coupon for Office. So it's a valid coupon that will reduce your rate. The way that you get that coupon is you go to that little tiny site over there and you type in your information. And let's say it's about this author. Tell me a couple of words about Dave and his book, and tell me some great things. That's kind of that pay for play kind of thing. And so you go in and you type in this eval about his book, and they give you the free coupon. But while you're on that site, while you're typing all that information in, remember, you clicked, you went there, they're delivering malware to your device. Or they don't deliver malware to your device. They say, here's a downloadable copy of Office right here. And when you go to key in your license number, when you go to buy your license number, use this coupon to get a 50% reduction in the Microsoft Office store. What they do is they take the Office, they crack it open, they shove other stuff inside of there, and they put it back together. That's not really what happens. Is they take the Office and they wrap it around another program, and they have another installer that goes along with the primary installer to deliver it to you. So compromising a legitimate website, which is now called a watering hole, that's how they deliver their malware to you. We can't replicate that stuff, because if we are, then we're truly being adversarial in nature, and most of your customers don't want their end users suing them, so they don't allow you to do that. There are some instances when you're in military and government, or maybe even in medical practice, they will actually do those things, but we traditionally don't do that kind of stuff. We look for drive-by downloads, USB drives insertion, and then malvertising. It could be done through network propagation, and that's a service vulnerability. That does not last very long. When we have new vulnerabilities that happen out there and they are on the CVE ID, and the score for the CVE ID is like a 9.8, 9.9, or even a 10 every once in a while, that's probably a service vulnerability that lasts for as long as it takes for everybody to patch their machines. So that doesn't last very long. That is my 10 minutes on malware. That's all we have time for there. I wanted to point out how that's set up for the exam and then just kind of like run away from that. There's no good labs in this. It's not a lot of fun to do, but there you have it. So questions, pocket deleting the drive, right? Questions about malware before we move on to web servers. Questions, about 60 seconds here. And I think that brings us to our first break. If you're good, throw me an exclamation point. If you're asleep, throw me a question mark. Okay. Excellent, excellent. Okay, we got about 26 in the class today. So we will be going in and out for each one of the sections. What we'll have is we'll have the discussion, we'll take a break, then I'll do some demonstrations on some labs, answer some questions, take another break, and we'll just do that over and over and over again. If we have time at the end of the day, I have a whole section discussion on OWASP Top 10. I will tell you that we never get to it, and I have a recording for it in the library. Thank you, AD. I know you're not asleep. You're the first one of the first people to ask a question. Okay, so let's go ahead and take a 5-minute break. We'll run away, go play, and when we come back, have your hacking web servers open, your mind map open, and we'll do a little discussion there. All right, I'm mute for the break. Welcome back. So we're going to talk about web servers. The way we're going to do today is we're going to do a discussion. I'll show you a couple of tools that you can use. You can use them in class against the expsec.us site if you want to, or you can just look at what I'm doing there. And then I'll do a couple of demonstrations of some technical tools. We'll do a little bit of quiz question stuff and move on. So it'll be that progression it'll probably be about an hour and 15 minutes per section that we do here. So we'll get in a break about every 25 minutes is what we're doing today. Okay, so for web servers, let me scoot this down. There we go. Conceptually, now, we have to separate ourselves from the application layer attack. And this gets real fuzzy because web servers, web applications, and SQL, it's all the same stuff all shoved together. So we're arbitrarily breaking these three things apart from a conceptual standpoint. Okay. And normally what you would say, well, why isn't this system hacking? I asked you previously, what does a normal server look like? And the response was one IP address, one or two ports, a single service. You can't do that for most of web services because there's more to play with on a single server, and it's always different. Usually, if you have like a big attack surface, it would be like Linux, Apache, MySQL, PHP, and then WordPress for a content management system on top. So that would be the LAMP C be the LAMP CMS is really what it would be. That's the most parts that you can have as an example of a big attack surface. Then there are other websites that are out there that have no attack surface whatsoever. An AWS S3 static page is a web server, and it does its job, but it's one page, and there's nothing to attack. So when you walk into any kind of web services attack or look at any kind of attacks that are out there, when you start off, you have to figure out how complex is this? How many different servers are there on the back end? What are the moving components that go along with this? Because a static page, that's a 5-minute test. That's it. But the other ones, it could be, 15, 20, 100 hours. So what that comes to is there are so many different kind of configurations out there, and there's no perfect architecture for us to look at. And a lot of people will say, remember at the beginning of last week, I said, we have a firewall. You talk to that guy out there, right? Well, fine, but the firewalls have to allow anonymous in. They've got to allow it into the web server. They shouldn't allow it into the database. And then there's a little bit that they're supposed to allow into the application. And this place right here where a little to the application is the place that we as testers are testing the user implementation to make sure that that little is what we call in the defense game least privilege, just enough to do the job and nothing more. So then what we have to do is we have to really talk about the client server process and how it is also different. So user enters the URL into the browser. We could go right after them right now and falsely resolve, but we have to have that resolution for that web client from that web server. You can attack that entire process, and that can be a whole world for you. You can just use that on the client side of things doing beef. Traditionally, what happens is we don't attack real clients. What we do is we say, for your web server, how many different clients do you allow into this website? What are the different browsers that you allow and clients that you allow based upon the signature coming to you? And then what we do is we set up all those different clients in different variations on our side, and we attack through that client, or we attack that client as it's attaching to that server. We fake the person in the middle. So once that happens, now there's a couple of things that can happen. Static pages, the simple web pages, they have their own extension on them. And all that is, and what a web server starts out to be, is just a file server. That's its very first function. It's just a file server. It doesn't do anything else. As soon as you add the login page or any entry box that is other than on the URL line, then you need a way to process that. And there are many different ways to process it. PHP and ASP are the standard examples. The web server has to process it in some way. Is that logic done on this box, or is that logic done on some other box back there? And how is the handoff done between them? It's your job to map all of that process and to figure out what that is. The best way to do that is to build a bunch of websites. And I mean, like, for work, build websites for your house of worship, build them for the shelters that are in your area, and build a whole bunch of them, and do that as free work for them, so that you can get used to how websites are actually built and all the different things that you run into. I build about 5 new websites per year using whatever technology the person requires on their side. And there's all sorts of requirements for all sorts of different organizations that are out there. One of the things where I look at, like O'Reilly, they require me to know nothing about you and to keep it that way. I can't say, hey, can you send me your email address? What I can say is, hey, can you send me your fake email address that you've created and your pseudonym so that I can give you an account? That's the closest that I can get. So that happens a lot with different businesses that are out there, where I come in and they say, okay, we can't collect any data about these people, but we have to enable them to be able to be in a meeting once a week. How are we going to do that? We need to allow anybody that wants to post to go ahead and post in this way, but we don't want anybody from the outside to do it. How do we do that? And so that work that you do there helps inform your way to learn how these components are built. Just by building it without having any users present doesn't really do any good. So let's talk web server just for a second here. And it's going to store, process, and deliver files. It is a file server. But the components, they can vary. Now, here's an example of a set of components, like the document root, the server root, the virtual document tree, the virtual hosting, and if there's a web proxy involved. You can look on, if you look at Amazon's validated designs, so you can look up the AWS Validated Designs program, and you can look at the web servers that they have there, and they'll show you 20 or 30 different components that are there. Like when I set up content management systems for schools, O'Reilly's not really a school, it's a content delivery system that they have there. But when I do it for higher education, they want me to build out a tool, and you're going to use that at VMLT, which is called Moodle. A Moodle instance that is good for 1 million people is a really complicated thing. But really what it boils down to is a web server that has a memory capacity for each user. And that's what it comes down to. Whether it has e-commerce on it or not, that's very dependent upon the particular school that's out there. What's the architecture look like under this? Now, there is no one architecture, but generally it breaks into kind of 3 sections here. We have the client, the web server, and the database. And so that's how we break down today's discussion. On the client side of things, is it a laptop? Is it a phone? It's probably going to be a mobile device today. That's pretty much guaranteed. But then what browser can you use? When I'm on this phone right here, I can use 5 different browsers on this phone right here. Now, this phone, since it's an Apple phone, is limited for those browsers to what's called WebKit. And I have to know that that is a self-selected smaller set of services that can be delivered to my browser through the controls that Apple has put on this. That's very different. There's no WebKit on the Android side of the house. Well, they have something else a little bit different than that. Now we go into the web server logic layers. That's got all this other stuff in it. And you never know what's going to be inside of here, but you're always looking for these things. Now, what you're really looking for as a penetration tester is this one right here, the middleware. Usually that's in the form of something like .NET or Java. But for me, I was dealing with a really large institution that had 60,000 businesses that worked with them. And those 60,000 businesses had millions of users for those businesses. It was a kind of a school kind of thing that was out there. And this was a really large enterprise. And what they said to me was, we want you to do the testing on this. And so we made a copy of their entire infrastructure over to a different section of the cloud, a different region of the cloud. And I went in to do my testing, and I was the only one there. But it was an exact copy of what their regular infrastructure looked like. I worked for like about 3 or 4 days straight and could not find any way in. Nothing all along the way. And they gave me another set of credentials. They went up to this next level. And those credentials allowed me to look at a little bit of the site. It's the administrator of that group of users for that company over there, so that, they have 60,000 companies that they work with, and each one of those has an administrator account. That administrator account lets them let in as many users as they have licensing for. Well, that level of account had access to, and tell me if you've ever heard of these things before. Sorry, I spelled it wrong. Has anybody heard of standard in, standard out, and standard error? If you have, throw me an exclamation point in the chat. And it's important to know there's 2 different groups of users in here. If you haven't heard of it, throw me the question mark. If you have, throw me the exclamation point. First off, this was a Windows web server front end. Standard in, standard out, standard error, that's Linux psychobabble. That's not Windows. Why is this? And that's what I thought. I went, why are these things here? Okay. But they were files. They were log files. This server had been running for like 6 or 7 years, and it only had internal test. And I found, the first thing that I found was that they were using remote desktop protocol to get in. And so I told them they had to harden that thing right away, because that's Swiss cheese. And so they solved that problem. That was the first problem I found. Work, and couldn't find anything. And then I found these 3 files on the machine. They had this thing. It was a Oracle middleware thing called WebLogic, and it happens to be it happened to be an old tool that they were using for middleware. The marketing people said, we need to use WebLogic to do our analysis of the site traffic. So it gets put onto the site. Okay, fine, we're good. Okay. But that thing was generating, what they were doing is they were parsing those 3 files on that machine since the machine had been built. Every bit of input, output, and error. The error file alone was like 50 megs. That's the small file. Standard in and standard out were so big, I had to figure out a way to slice them up. I could see them on the machine. I could do, like a top and a tail kind of thing with the Windows kind of tools that are out there, looking at those files. But they were so big, I couldn't pull them off of the server. My difficulty was carving it into small enough pieces to pull it off, reassemble it, and then show it to them what I had found. But the standard error file alone had hundreds and hundreds and hundreds of credit card details in it. And it was like, oh. So I never found anything else. I found 2 bugs on the whole, but if somebody else would have found that, I mean, could they have cleaned off those files on a regular basis? Yeah, they could have just written those files out to some other location, and the people could have they could have done the analysis for the marketing team on the backside, and it would have been just fine. But see, the standard demand for that server was all rock solid. Even though it was a Windows implementation and everybody says, oh, Windows sucks, it's like Swiss cheese, they had really rock solid hardened this thing, but they had added that one other thing inside of it, and there was no way for me to see it except for because I had this one, just this little bit of privilege and I don't know why that administrator had the ability to look at standard in, standard out, standard error. I have no idea how it was set up in that way, but that's what I found. And that's middleware. And that's the place where you're going to find that somebody who has nothing to do with security makes a demand of that organization that opens up this giant hole. And so that's why I talk about middleware. A lot of these other things that you see on a regular basis, they all define how the data flows, how it's stored in the applications, and how it integrates with legacy applications. Those are the places that you are looking for this stuff. Next is a database layer, and I'm going to say run away for now. That'll be our last topic of the day. When we do web server penetration methodology, it's a little bit different. We start off in the reconnaissance by doing web server footprinting. So let's look at web server footprinting. There are 2 tools when it comes to the reconnaissance. I'm going to drop these 2 into the, you don't have to click on these, but I want you to, and you can see that they're there. But those are the 2 different websites that I'm going to. And I've already done this, so don't click on them because it's unnecessary because I'm going to do them. So the first one is what's called the SSLlabs.com. Qualys started working with a gentleman, and I can't think of the name of his website right now. Feisty Duck, there it is. And he does this, he does really great training on it. And what he does is he says, okay, you can look at how your web server is doing. So this gives me a report, which is an overall B. That's what I get for expsec.us. If we look at it in another way, this is the Netcraft site report, and you saw this at the very beginning of the week for reconnaissance. It tells me all the general details about this particular server and where it sits. So you can look through all of this. You'll notice that it's not susceptible to Poodle. It's not as susceptible to Heartbleed. It talks about the sender policy framework and the DMARC, which are, those are mail server material that comes off of that, what kind of web trackers it does, and you'll notice it says no known trackers are identified. In most cases, those web trackers that are inside of there represent a toehold into that server. I don't put web trackers on any of my websites. There's no X bug, Facebook bug, Instagram bug. None of those things are set up on my sites. This is usually a place where you'll find a lot of good stuff. Then we talk about the different site technologies, the server side, the PHP, that kind of stuff, client side and what's available there. And we get to, and we find out that fabulous thing about WordPress right inside of there. Ooh, yeah. Okay. And so that tells us our basic reconnaissance. Did I go to expsec.us.com? .us? Nope. I went to Netcraft. So no footprint, no visibility from the client side. Did I go to the site? Nope. Qualys actually went there and they hit the site. They tell me all these great details here. Now this report, by the way, when you run this report, this takes a long time and you'll see it. They'll give you a percentage bar at the top, but it can be, depending on the complexity of the site, this can be 5 to 10 minutes for it to run this. not because it's trying to kill the server or overwork the server, but because it's doing a lot of process on the back end to generate all these pages. Talks about the certificates, and are we doing certificate transparency? Are we doing the OCSP multi-staples and the no? And I get dinged for this, for not doing the staple there. Talks about the certificates. Now, these are very basic certificates because they're run by Let's Encrypt. If you look at those, tells you about the configurations of what protocols it supports. Bigger sites with more customers that they have will support lots and lots of backward compatibility. By having backward compatibility back to SSL 3, you're now susceptible to things like Poodle and a couple of other things that are out there like that. So then it talks about the cipher suites that you're supporting. Here, let's look at these ones right here that it says weak. You could say, well, Dean, from a configuration standpoint, we'll turn those things off. And what you've said is, yes, but you're going to disenfranchise a percentage of their customers. So know the implications of you saying, I can attack this way. And they say, yeah, but we want those customers. So we'll take that trade-off there. Everybody that's doing 2 versions old of Android, who is 20% of our customers, they use these cipher suites. That's all that particular Android device can handle. And therefore, we can't just chop that off. We need to add other controls in some way, shape, or form. By the way, most of the things that will solve this are really simple things like CAPTCHA. And you can get CAPTCHA that does not require you to fill in any blanks. It can be set up on the site and work just fine without user input. The CAPTCHA version 3, I think, is out there. So you can use that as an offsetting control here, but that's for defenders. For us, what we realize is that all these protocols that we support also tells us that we're able to support, like for instance, and here's that example, here's the older Android at this point. I do not support Android 2.3.7, but I do support 4.04. So, you know, I'll support all of these things inside of that server, and that represents a risk to the organization. You looking at that say, okay, these are all the servers that they support. This becomes your list of all the different browsers that you're going to test through in any kind of proxy server that you're doing. So it gives you that big, long list there. And then what protocols does it support? And in the protocol details, we say, are we susceptible to Beast, Poodle, Zombie, Golden Poodle, Sleeping Poodle? I don't even know what that one is, to be honest with you. Heartbleed, Heartbeat. And so there's a whole bunch of different susceptibilities in here. You should automatically, with most websites in this protocol detail, get no. If you get anything right here, something seriously wrong with this site, you can look at any one of these and you'll see that there's like more information here. Any one of these has an exploit, and it's probably in Metasploit right now available to you. So if you see a yes in here, with the exception of forward secrecy, but if you see a yes to any of these vulnerabilities in here whatsoever, it's in Metasploit. You can turn around and you can exploit that instantaneously. Now, you should be doing your scanning and you should be doing your enumeration, but it might be that you have in your contract, if you find a significant flaw that represents a significant failure to this organization, you're required to immediately stop the test and report that to one of the senior leaders. That's happened to me. I've had to stop the test a couple of times. That report gives you all the basics of your reconnaissance, but it doesn't look at the website. This is passive reconnaissance that you've done here. You can do it with either one of these two. So that's our reconnaissance phase that we're doing right here. Let's go back over and talk about the scanning. The scanning is a little different now. Yes, you can scan for the open ports, but we know at least 80 and 443 are going to be open. So then what other kind of scanning should we be doing? What should we be looking for? It's not quite enumeration at this point. What we do is we do the function of website mirroring, get an exact copy of this site locally for us. And then we reveal codes on every one of those pages, and we look for input dialog boxes. That's really what we're looking for. Can we look on the normal site with the normal input dialog boxes, and can we use automated tools to do that? Absolutely yes. Portswigger is your best friend in the entire world, and there's NetSparker and a whole bunch of other tools that are out there that are available to you. But the basic construct is a website mirroring that mirrors all of the pages of that, because we're looking for that leftover residue of garbage that they forgot to take out while they're programming. Another tool that we could use at the scan level for website mirroring, if we wanted to, would be the Internet Archive, sometimes called the Wayback Machine. Now, after the scan, we may do an enumeration, but usually our enumeration is those web pages. We don't get any other enumerations because there's no other services on there unless it's like a small business server. But now what we do is we do the exploits. For exploit, we do the exploit finding. We're looking for unpatched services that are available to us. Because of the different architectures, this is where exploit finding gets tough, because one person's going to do it this way, the other person's going to do it that way, and I want to say that there's probably 18 major architectures out there that are perfectly valid for that business versus that business. And so exploit finding is going to be a little tough because the components aren't lined up and patched up the same way, and sometimes we'll have compensating controls for those things being in place, like Apache struts or something like that. Next, in our exploit, we would do any kind of session hijacking. Now we're looking at what we talked about yesterday with the hijacking. We're looking at that interception methodology. This usually requires a proxy server to do the session hijacking, because we hijack ourselves, our own session. We don't hijack real users that are out there. Next level of this is going to be some form of password hacking. You saw what happened with our site at the beginning of the week. There was a default password and we got a hint. Remember, the website mirroring would have said, hey, go look at Discord or go look at this frequently asked questions page on our intranet site. And it happens to be that that is available to the outside world, and it says the default password is this. You could use a tool like Hashcat if you wanted to, and that is at hashcat.net. Do you do maintaining access for your server? That depends on how things are set up. Do you do the covering tracks? Not as much. You do the first three, and then you're kind of done at that point, unless this is a really big e-commerce server with millions of users on it. Then you're dealing with something else. Okay, for protocols. The protocols for web servers are simple. It's going to be 8443, some form of a database that may be direct or indirectly connected, and hopefully, I hope all your web penetration tests have middleware. I wish you good fortune for middleware that's out there. Okay, now for techniques, you're going to find proof of concept. Sorry, I couldn't get the word out in a database. The two places to go are either ExploitDB or PacketStorm. Those are the two places that you want to go to look for proof of concept. I like PacketStorm because it is because the proof of concepts are doable right out of the box. They show you exactly how those things work. We can't do them in class. I would build up a couple of web servers in a couple of different versions to go ahead and do the proof of concept there. Learning how those individual people build their proof of concepts. Sometimes you look at them and go, that's pretty weak. Other times you're like, oh my God, this is perfect, but it's all proof of concept. Then you can go after the web server itself. Remember, you can do a takeover, like a directory traversal. The classic example of that is Rainforest Puppy abusing the local system executable. And you may say, Dean, I've heard of Rainforest Puppy. That was against IAS versions 2, 3, and 4. That'll never happen again. We don't have that kind of problem. 4 or 5 years ago, Adobe's main website, their core website for doing Adobe Connect, which is it's like our On24. They have their own version of it. Adobe has that. It used to be called Breeze, but they were susceptible to directory traversals like 4 or 5 years ago. And these things crop up all the time. Now, they could be set up as farming connections for bot sites and malware, which we talked about previously. We could consider redirecting and using that as a major threat that's out there. We start with DNS, see how we can go ahead and take that over, looking for the redirection to another web server. You could, in theory, do what's called response splitting attacks. They don't happen as much these days. Weird applications are susceptible to those. Or straight up denial of service and doing a defacement on it. Now, I said at the beginning of today that where this would lead to would be the OWASP top 10 that happens at the end of the discussion today. If you learn nothing else, OWASP web server top 10 is a perfect thing for your exam, and I want to talk to you about the level of it. So you should be able to have each one of these committed to a note card, that at a minimum. You should be able to explain what broken access control is, cryptographic failures. This has been done so well by OWASP that I just don't do it in class. They have great examples there. And when it comes to doing your labs, there is something called the Web Goat and the Web Wolf. And you want to look at the Web Goat and the Web Wolf. I'll talk about that in the labs section. But these are the top 10 that you have to know. And 2021 is sufficient. There are a couple things that have fallen off the list as of 2017 list. Do the 2021 list. It's perfectly valid for what we're talking about here. But that's a straight up memorization. And if you're going to be in this world, you'll realize that OWASP top 10 crosses web server, web application, and even into the SQL servers itself. So it's a great, those 10 on a note card kind of really make it work well. From a testing implementation, we'll be breaking pretty quickly here. Decide if this is your world. And have you been a web developer or a programmer before this? Then this is a really great place to go because you know all the mistakes everybody else has made. Dig into OWASP. And for your documentation of recon, you also might want to look at Dimitri. This is the business side of things. From a threats side of things, what happens is all of these problems that we're running into here, all the different things that are on this list, they come down to end user implementation, demands from somebody internally that is not a programmer or nor is a security person, nor are they an architect. They're, especially on the web, it's some form of marketing that's out there. And so they will demand that these people put a product in place that are going to reduce the overall security, and that's where you're going to take advantage. Again, I'll go back to it and say it again, middleware is your friend. For controls, is there a patch? Did they custom build this machine themselves? Did they custom build this application themselves? Because there might not be a patch for it. Is this software as a service where you're buying from a Salesforce? Well, when they roll out a patch for that, that patches every single one of their customers all at once. We're not allowed to test Salesforce. It's very clear. In most software as a service, we're not allowed to test it unless that company owns the software as a service and is allowing us to get into it. So we can't test for it. We can't look at it. When we look at the patching, we're talking about software updates for vulnerabilities in vendor code. Who wrote the vendor code? Was it you, or was it somebody that you bought from? Was it Oracle's WebLogic? Was it WordPress, or was it a plugin from a vendor that supplies that to WordPress? This could have a whole bunch of different names out there. You generally have to know for the exam that the patch and change management all falls into this process where businesses involved in this. What we need to do from a defender standpoint is be fast about this, because as soon as a vulnerability is listed in the CVE database, then the attackers are going to start attacking it. That means that if nobody's patching, then as professional penetration testers, when we come in, we can test how long it takes them to deploy those patches, because we go in there and test and see, oh, these patches are on the machines and we have exploits for them. We know that we can attack that. But the defenders, they have to get really good at this really fast. They need to be able to do the simple process of detecting, assessing, acquiring, testing the patch, deploying it, and maintaining it. Patches fall off of machines primarily today because of reversions in a virtualized environment. So like if you have Broadcom's VMware, because that's now who owns it. If you have Broadcom's VMware and somebody rolled out this machine, deployed a patch to it, and somebody says, hey, I have to roll back for some other instance. When they roll back, the patch falls off. So maintaining the patches in a virtualized environment for web services becomes very problematic. I think it happens across the board, but they put other controls in place. Okay, now that's web servers. Generally, I gave you a little bit of work there. What we're going to do is I'm going to do a demonstration when we come back, talking about a little bit of web server technology that's out there. And then what we'll do is we'll dig into, I showed you this lab, so we don't have to actually do it. But I'll talk a little bit about this, and then I'll ask you some questions. So with that, run away and go play just for 5 minutes. If you have questions, post them into the attendee chat. Okay, welcome back from your break. Now, you've got the links for the simple recon. Please don't do these against live sites unless you've already got a contract with them. They're a little invasive. The one thing that I wanted to point out to you, which is kind of cool, some people don't like using Netcraft or a third party out there, and they want to use their own version instead of Equalis. What's really cool is inside of Kaylee, there is a local installation of this called Test SSL script. And it gives you almost the same information as the SSL Labs test. So I really like that, if especially for military clients where they can't use those external websites, or you're using like an intranet site, you can use the Test SSL script and it will get you almost the same results. Okay. Now I want to point out Lab 13. There are a few issues with Lab 13. If you look on Lab 13, you'll see that it says exploiting the Manage Engine Desktop Central and Apache Tomcat. In the standard lab, when you do it at AWS, you do not have access to the to log in to the Windows server. You just don't. If you have local instances of the VMs for Windows, you can log into it. You got to ask me for the password. And then what you can do is you can turn on the Manage Engine Desktop Central number 9. It's on the desktop, and when you load the desktop, you'll see it sitting right there. Once you've logged in, you double click on it and it runs the service. But until you log into that machine once and start that service, you can't do that lab. Okay? It's an excellent lab. It's part of Sharma's labs that are out there. It's page 4 through 8 in that lab. So it's just one of these weird things that you run into, okay? So then on Lab 14, it takes 20 minutes to build. The lab is 20 to 40 minutes each, and there are 8 of them that you can do right here. And here's your exploit, and it explains that exploit if you have to do Poodle. When you run up against a client that their web server, when it was scanned with SSL Labs, says it's susceptible to Poodle, then this will get you where you need to be. Today, what I say is it's very rare that that happens. So is Lab 14 a great lab? It's good for practice. I think that there's going to be another version of Poodle, just like there was. There was a Golden Poodle was the next version of that. So I think there are going to be variations on this theme once we've figured out how to do this. And that's why Lab 14 is a reasonable lab to do. But I have some other labs that I want to talk to you about in just a minute. Okay. Now I'm going to leave the questions slide up so that you can ask questions as we're going along in this section. But I'm going to switch over to a demonstration. So what you have in front of you right now is, instead of using Kaylee, I used Parrot. For the CEH, if you're doing the practical version of it, you have to use their operating system that they give you inside of their environment, and it is Parrot. It's no different. It really, truly isn't. I have yet to find a thing that that I can't do on Parrot that I can do on Kaylee. And if I can't do it, then I load the binaries from the original location, and then Parrot does what Kaylee does. So it's not that big a deal. So when we start off in any Linux environment, the Linux people know this, that you have to sudo. I like to, for labbing purposes, I like to sudo interactive. That's a sudo -i. As long as you're not doing As long as you're doing multiple commands that are on the penetration testing side, sudo I is good. But if you're doing actual installations of software, it might be that you just need to be able to install that software, but not do it so you'll do the sudo command over and over and over again. So that's why I did that. And what I did was, the first thing I did was I wanted to do a scan against this website. It's called moviescope.com. And so I used NC, which is netcat. And I said, do a very verbose, that's the VV command of moviescope. And it says, okay, I'll go ahead and do that for you. Tells you what IP address it is, tell you what port it's on, and it does this. And basically it does a website mirror. And so if you look at this and you're familiar with these details here, all this is a website mirror. It's nothing more than that. And by the way, this site is really, really stripped down. There is no Moviescope live on the internet. It's owned by EC Council. You cannot test against it. You're not allowed to. But if you're doing the EC Council iLabs, you pay $200 for those labs, then you'll get the ability to do Moviescope. You'll be able to attack it on the inside. Okay, so fine. Now I've done the netcat at this point, and one of the things that I get out of it is the banner page. This is kind of your low-level reconnaissance, but now you're doing active reconnaissance because you pulled a page from it, and you see that it's a Microsoft IIS server powered by ASP.NET. Okay, that's good. Okay. Now what I decide to do is I decide to connect to it using Telnet. So now I have to know what my interactive commands are for the HTTP protocol on that local machine. You'll notice that I'm going over port 80. It's not 443 at that point, so I don't have any certificates in the way, and I can capture all of this in like my capture tool. So I have to know that I have to type in the get HTTP. I get the exact same information out of it. It's just another way to do the exact same thing. Okay, so now one of the things that I did was I put little markers in this so that you could see if you were looking at the EC Council's lab and you were looking at the you were looking at their steps there, then I made sure that you could mirror it to my steps here. But this is also for something else that I'll explain in just a second. I run nmap, and here what I did is I said, okay, I'm going to do the SV command. I'm using one of the scripts, which is HTTP enumeration. It's not the same kind of enumeration that we're thinking here. And we could do this one. This one's against goodshopping.com. And it takes it a whirl. And it comes back and it says there's a whole bunch of open ports on this machine. Now, you and I know that this shouldn't be, okay? The remote procedure calls, the ones from 2100s in there, they don't count. But look at that bottom one right there, 3389. That means that terminal services remote is available to you. I want to say to you, if you want to pick on one piece of software over and over and over again, it's terminal services. It really is just, I don't want to say it's Swiss cheese, but it's Swiss cheese. I mean, I don't have any good way to talk about it. It's every time I see the terminal services there, I'm like, that kind of thing. Okay. Now you'll notice that we've got a weird 1801 here, which is the Microsoft MQ question mark. That one looks a little weird. It's by the way, it's the database. We have the 139, 135, and 445 open. We know all about those. That's our net bias. That should not be happening on a web server, but that misconfiguration happens 1 in 20 times. I wish you good fortune to go ahead and find that particular thing happening. Okay. So then what I do is I say, okay, let me try and run a couple of other scripts. Now, I'm not running the kitchen sink against this, although I could. So I'll do another nmap, and this time I'm going to do the host map. And I'm going to say, here's my prefix for this. Tell me what's going on there. Because, you didn't get anything else. I mean, that's really what you get down to, okay? So you can do it. You can say that it's scanning. Okay, so now let me try the trace. And now what happens is in my trace, sorry about that. There it is. It tells me from me to them, how do I hop through this thing? It happens to be that I'm local to this machine, so that my trace isn't going to do me any good. So I know how to get there. I know what hops I have to go through. And then what I do is I do a port 80. Now I like this script. This is HTTP WAF detection. So is there a web application firewall available here? This is not a bad script. A web application firewalls can be on the machine. It can be between you and the machine. You have to be prepared for it. You'll know that, like, if you go to my website, I've put word fence up there, so it's on the actual machine itself at the content management system level. Whether that's good or bad, that's up to you. So when I run that script, it says it's detected, but we don't know what kind it is. And so we know that it actually exists there, and that's all we get out of that. So that's the end of that. That's the Nmap scripting engine. We saw the other ways to do it, but remember, I've always said this: Nmap is your friend. I mean, it's kind of like the perfect tool that you have out there. Okay. So next, we're going to look at a dictionary attack and how we would actually do that. Again, we've got Parrot here, same host that we're dealing with on the back end. We're going to take a little peek here. And one of the things that I did, and this is what I wanted to share with you, I know it's a little bit of a squint here. I have my own DNS server that I own. It's called clickalab.com. There's nothing there by design. Actually, one day it will be a product, but there's nothing there. But what I have set up on that site is I have all my DNS monitoring going on with that website. It logs all activity to it, especially failed resolution. Now, if you look at this, you will see it's clickalab.com, a subdomain of num0, which doesn't exist, a subdomain of that task1, a subdomain of that lab2, and a subdomain of that module 13. None of that stuff exists. I say that because what I do with my team online from a professional standpoint is if we're doing all of our testing at the same time, I change this into my initials, the task that I'm on, the tool that I'm using. Basically, it is on-time documentation, third-party resolution of what I'm doing. So on my local machine that I have the Wireshark capture set up, I see that I've done this thing, and that is corroborated by my DNS log out there on the internet saying that we have an entry there for this. So I said, I'm doing this at the same time, and it logs that one activity. Then when I'm finished that activity, I send another message back to it to say that I'm done that activity. All the packets that get captured in that Wireshark packet capture from then on out are, I don't want to say they're forensically sound, but they're as close to forensically sound as I can possibly get. These are all of my activities that occurred, and the start and end were corroborated by a tool on the internet separate from me using DNS and ping. So it's a cool little tool. That's mainly what I wanted to show you here. But then you can see that I'm doing the Wireshark capture here. I like doing T-Shark, but I did Wireshark so you could see it here. And now what I do is I do an Nmap against that particular host. It says that 21 is open. I know FTP server is open. So I just went after one port, one IP address. I know it's there. You should be doing this Nmap scan against those internal hosts, and you'll find that port 21 is open. So when I try to connect to FTP, then I have to supply, it replies back and it says 220, I'm on Microsoft FTP server, give me your name. Now, I don't know what the key is at this point, but I have to key in something, right? So I key in admin to see if that works. Most of the time it doesn't work. Then it replies back to me and gives me a 331 message. Password required. Now, here's the hilarious thing. I keyed in the password that I think would never work. It let me in. And you can see I've got an FTP command line on that machine right now. Admin should have never worked. Okay, but it did. Password, the standard default password of the capital P A $$W 0RD. That's what I keyed in, and it worked. Normally in these cases, I just wanted to capture that information to know where those fields were to fill in. And I got lucky, okay? Most of the time you wouldn't get that connection, so I'm stopping it and I'm starting over again. And this time what I'm going to do is I'm going to get a word list, just like you do in all password testing. And now I'm going to use Hydra. And this is your first time to actually see Hydra down at the command line there. So I'm saying to Hydra, okay, where is the list of usernames? And that's all I've done there. Okay, so I've said, here's my list of usernames. You would have collected that and you would have built that into a text file, and you would have been tracking all those passwords that you caught, all the default passwords, all the passwords that worked, but then were also blocked by multi-factor authentication. You'd collect up all of those things and you'd put them into that user name file. You collect up the usernames in there. So it would be first name dot last name, first initial dot last name, the underscore, all those different kinds that you could do inside of there. Put those in the usernames file, and then the passwords is the next piece. I put the word list in there, and that's my passwords. And sorry that it wraps around down here, so you can see that it's wrapping down there. So 2 variables, list of users, list of passwords. Now what I have to do is I have to say, okay, here's my target. Now in this case, what I did was I gave it the FTP server itself. You can also supply a list of servers that you want to go after. It's better to go after one service at a time. So if you're going to go after 10 servers and you're going to test all of their FTP, then it should be all FTP servers that you're going after. And you can put all of those into a list. And so now you've got your 3 different lists that you're applying to this, and that will allow you to go ahead and do your passwords. It goes through, and you'll notice it says right in here, right there, it said, I'm going to try 238 logins, 15 tries per task. This is the default for it. And so it does however many passwords, multiplying the number of users times the number of passwords gives you 238 attempts. If there's lockout involved in this, you've locked yourself out. It might be a good idea to create a throwaway account, and the first list is your user list of throwaway account to see if it locks you out on the throwaway account. Like you're never going to be able to log in as the security administrator of the organization. So, but you have the credentials, and you're going to try and guess passwords, and you're going to see if it locks you out. And so you run 200 passwords against that one user account. It should, if there is lockout enabled and lockout possible on that service, it should lock you out, and you should know when that happens. You record that information, you put it into your file. Now you know what the lockout threshold is, and so what you do is you guess just under that, you take a break, you wait for a little while, you come back in again. You don't know what the threshold is there, so what you'll have to do is you'll have to program that in a batch script to run usually it's about every hour is about a good thing. So if you do it 61 minutes, every 61 minutes, you'll eventually get in with a really long password list. This is one of the things that you do at the very beginning. You set up your scripts for this. I'm not a programmer, but I can build a script that will run every 61 minutes with a cron job that will go ahead and take the next file, the next file, the next file in my carved up set of passwords. And I let that, when I first start my test, that's one of the first things that I do is I find all my services and I let those passwords run against those. And that's when I go to bed. I wake up the next morning and it goes, here's your loot. So then what it does is it gives me admin with a password. I found that in my file. I could look that up. That was my lucky guess. But now I have actually captured that through some form of brute forcing that's out there, and that allows me into the actual service, and then I stop. And so now we got to do a brute forcing attack. And questions on brute forcing, this is kind of the very beginning of, you could do this with web servers that are intranet servers. You could do it against any service that's out there, but this is one of the first things that we would do. We would try and find those fields that we fill in, which I'm going to show you later on in the SQL injection, but I wanted the simpler way to do it here at the start. Questions, comments, issues? Okay. Where does that put us? Oh, that puts us right at almost to our next break. Before we go to our next break, I didn't see any questions popping up there. Let's do some skills here. Let's see what you can use. List the tools that footprint a web server. I don't care what they are, whatever you have in your list. So now it's time, if you were asleep, it's time to wake up and go ahead and jump into Mentimeter. If you got nothing, you can throw me question marks, but then it becomes a note card for you to look up. For every single one of these questions that I put up here, I can guarantee you that you're going to see something like it on the exam, so you might as well start writing it out. Yeah, I don't mind Nmap. That's more on the scanning side of things. So I don't mind that. Yeah, there's what I was looking for. I was looking for a Netcraft or something like that. Because remember, and that's a definition that you have to understand for EC Council. Footprint is the overall space of the server. It's not the ports that are open. It's the server context, it's the banner grabbing stuff on the outside and all of that information that is publicly available somewhere else. So you can do passive reconnaissance footprinting at Netcraft. Question. NetDiscover. I don't know that tool, SL. Am I missing something? Test SSL script, SSL labs. Yeah, those are the two that we're really looking for. Okay. Thanks a lot, SL. You just gave me homework. Oh, that's in K-League Tools also. I didn't know that one. Okay. Good. I know a new one. Okay, now Nginx. Let's talk about that for a second. Nginx is a web server type. So you would get, as a result of your footprinting the web server, you would get that it's an Nginx server. So that's not a reconnaissance tool. All right, next. So let's think about your report data here just for a second. So you would know what the stack is. It's typically LAMP or WISA. That's Linux Apache, MySQL PHP, or Windows IIS ASP. I'm sorry, Windows IIS SQL Server ASP. Then you would get your password cracking. This listing is a must. You'd use Hydra to do that. Remember, the screenshots are very sexy, but you want packets as proof here. Okay, now here's your exam level questions for this section. If you're not strong in this area, that's okay, just mark it down. Here you go. You see the output below. What is this called? What do you got? You can look at the information returned here, and it should give you a key indicator. I don't think I'm going to fool anybody here. You must have in your quiver, to be able to compare and contrast these 4 things, you must have a clear definition of what cross-site scripting is, what is a whoas database query, and what are the results of it, what does SQL injection look like, and what a banner grab is. Next one. Okay, so how hard was this section for you? We're going to go to a break in just a minute here. Most of what we're looking at this in this section is web server infrastructure architecture. And if you're really struggling with this, the best place that you can go is, well, you can look at a bunch of different web server architectures that are available to you out there. Now, one that I love that gives me lots of different infrastructures that are very popular is Bitnami. So you'll notice that they have applications in enterprise, and we're just going to choose applications here. And I've got single tier, multi-tier, Docker, Kubernetes, and virtual machines. And then from there, you're going to get a list of different machines that are out there and available to you. And you can search on and see what you get for websites. Now you can't search websites there, but you'll get a bunch of different ones, the different tools that are available to you out there. Let's see. There's LAMP, one kind that's out there. But these are your different possible implementations that they've got for you. I know some people use Django. And I don't know what Doku Wiki is, but I do know it's kind of like a website wiki. But you'll get different ones that you can use here, and they're all pre-built for you. So you can look at what they are and see how they're set up. You can pull these images down to your local machine, or even get them in AWS, load them up, put them inside of your environment next to your Kali instance. You can poke at it and see what it looks like from the outside and from the inside. And so it also gives you the list on here, like, let's see, what's this say? It tells you what category this is in. Let's see if I can get to the ones for websites. E-commerce. I think the e-commerce has got a couple of things in it. Yeah, there's different e-commerce sites that are available to you. So you can work your way through those, use each one of those as an example of a standard site. The reason that they're here in Bitnami is because they're popular builds that people need. And what's cool about it is most of the people that are doing this are not perfect at their job. And so therefore, they're just trying to get something up there, and they're not doing a lot of security on it. It's owned by VMware. Won't be long before they start charging for a subscription. Oh, cool. Right now, if you don't know this, when Broadcom when Broadcom bought VMware, they basically lopped off a whole chunk of their customers. They said, anybody that's not willing to give us $1 million a year, go somewhere else, is really what it boils down to. $1 million a year is like the minimum subscription. It works, workstation stuff fine. I think what will happen with Bitnami is that they'll spin it off. I don't think that they'll kill it. It does have a subscription for the support services in it, but yeah, I don't think it's going to go the way of VMware at this point. But I think it'll get spun. I think it'll get spun back into Amazon will buy them and they'll incorporate them into Lightsail. I have no insider information on that. That's my guess. Okay, so that's a good way to get those set up to get with. So if you're struggling. If you had a few problems here and there, architectures, you could learn about them. And if you wanted to cry most of the time, support your local charitable organization and build websites for them. That's what I would say in that section. Okay, so now what we're going to do is we're going to talk about hacking web applications in OWASP when we come back from our break. So I want you to run away and go play just for 5 minutes, get a cup of coffee, come back. We'll talk a little bit more about OWASP. We'll talk about web applications and how that is different. With that, I am mute for the break. You know, those boys get that syrup in them, and there's no controlling them. They just go out of control. Anybody know what movie that's from? Okay. Hacking web applications and OWASP. So I put it up here. I have to beat this drum. So we talk about OWASP. I see I can't even spell it right. OWASP.org is the way to go with all of this. I'm going to leave the questions up here and go over to the mind map. Before we get started with that, I just want to step in, dip my toe in here for web server tools for your exam. There really are 3 tools in here. Dimitri, and you don't have to spend a lot of time on it, just 30 minutes using it as a recon tool. Then Metasploit. Now I put Metasploit up here and I said 60 minutes on it from a web server standpoint. And you'll notice that your basic commands I've had here, search, use, show payloads, set payloads, those kinds of do, set options, show options, exploit. You must know those commands and their definitions at gunpoint. Now, I don't use proxy chains. In the real world, we use tools like PortSwigger and NetSparker and a couple of other things out there, but you must spend some time on proxy chains knowing how to set it up. I will talk about it in kind of the next section that we're in. I don't talk about the EC Council labs, but this is one of those things for the EC Council. You have to know some really like ghost eye and skip fish. I don't know if you'd ever use this in the real world. And for enumerating the web servers, they used Mmap scripting engine, which is I think is great, but then they use Uniscan. I would never use that in the real world again. But if you're going to take that test, you have to know this. So for anybody this is the last time I'm going to say this, for anybody who is doing the test for EC Council and you're doing the advanced test, you're doing the practical, you have to know each one of those tools. Now, generally what I would say is on the professional side for a web client tool, Beef is your best tool. It's free. And then the 2 tools that are like the top, there's 3 tools. There's NetSparker, Burp Suite, and PortSwigger. I'm going to talk a lot about PortSwigger in a little bit. But NetSparker is 2K and Burp Suite is 400. And I would say that if websites aren't your specialization, but you understand web servers and you have to have a practice in it and you really don't want to like really dig deep into that practice. For me, I would hand that stuff off to somebody like Sunny Weir. I'd just go, here, you know, she's part of my team. I go, here, take care of this. Go ahead and do this thing because she knows more about it. But if she wasn't available, what would I use? I'd pay the $2,000 and use NetSparker to get me good information. And that would be sufficient. I'm not an API guy. I don't play one on TV. I'm not a programmer. I don't play one on TV. I'm not a database guy. Yes, I have database certifications and credentials, but they're nowhere near the skills that I'd need to go ahead and make this work in the real world. And so that's why I would flip over to NetSparker. I like Burp. I think it's really good. There's a whole bunch of things. That's a PortSwigger thing. I think that's where it kind of all lands. And I'll get to labs on that very thing later on. Okay, now web applications. You want to call this Web 2.0. You want to call this Web 3. It's participation and collaboration. It's going to generate things that we didn't have to contend with before. Application logs. We're not talking about a web server log like when you step onto it. We're talking now about application logs that are separate from that. Any kind of advanced gaming, dynamic sites, not so much RSS generated syndications. Those things are nice. They don't cause a lot of application work to be done or a lot of testing to be done because it's kind of a broadcast technology, excuse me. But we're talking about user-centered design. Really, that comes down to social networking sites and maybe wikis. You see the wikis on GitHub. I have a wiki page that I put up there, but it's not truly a wiki, because a wiki would allow anybody to make pages on my site, and I have it set and restricted so that you can't do that. A wiki anybody can post to. From a testing standpoint, let's just stay inside of exploit. We've talked about the other things on the web server. We're deep inside of this. We're looking at the web application itself, gaining access and privilege escalation. Now, you all kind of did that. Remember, we went to expsec.us and we logged in, and then I said to you, document what you can do on the machine. If we go there right now, on the tester success page, you can see that this Pearson VD came in and said, hey, I'm going to try and do these things. And this was what I was able to do. I was able to create this post from Darth Vader and then from Ben Kenobi, and they're all pending. I was actually able to log in as Anthony Montgomery here and try to do other activities, but they listed off all the activities. And the way that he did that was pretty ingenious. He waited until the server was slow, and then he knew all his logins. So he logged in, tried to do something, and then he just listed it off. And so, and that was the really easy way. And then all I had to do is take a screenshot of it at that point. Now AS did some really amazing stuff. And because they made the joke about Dune, the Fremen, I actually put up the picture for them. But then what they said, I was able to log in using the below accounts to do XYZ. And so, again, details there. That's what we want. We want all of those details of what you're able to do. That's typically what you're paid for in compromising web application. But it's not that. It's not WordPress. It's the company built site, the company built application. That's the difference. So we can use a content management system like WordPress with all of the ways that we can change that. And you can add all sorts of different roles and kinds of things to WordPress and make it much more than it ever was intended to be. But that's a content management system that is pre-programmed with lots of plugins that you can adjust and tweak. When we talk about web applications, really what we're talking about is that custom built stuff for that organization. I've only tested 2 custom web applications, and I've talked to you about both of them. The worst custom web application ever was an organization had their own in-house developers, and what they did was they sold training for a living. And they had inside of that content management system, they also had their sales, kind of like their version of Salesforce inside of that custom application. So all of their leads that they were generating and populating inside of there, what they did was they went out to a lead generation company and they said, we'll pay you $75 per qualified lead to give to our salespeople. And then the salespeople would have this list of the people that they were supposed to call and sell. And it's inside of the same training system, the same content management system that's there that they custom built themselves. And what happened was they allowed regular end users who were going to buy training on the site to have a test account in the test training. And you could self-subscribe to the test account for test training. They didn't realize that the test account for the test training, one of the things that you could do is you could upload an image for an avatar. It wasn't the avatar setup like we have today, but this was your custom image of you that you could load up inside of there. And it was basically it's an open field that would accept any blob that's binary large object. It would accept that. The problem was that when it accepted that, it didn't parse that until after it was inside the machine. And one of the things that it did was it did a full line by line parse rather than turning it into an image. It actually parsed the file, and it turned out that that was malware that allowed that particular fake user to get inside of the system and gain access to all of the potential customers. And it didn't get to the potential customers after they were listed in the system. It found the file on the system that was about to be loaded in through a piece of automation onto that machine. So every time they went out and bought a new set of sales files, they would buy them, they'd sit them in the machine, they would wait until their salespeople had gotten to the end of the month, and then they would release the new list, kind of like Glengarry Glen Ross. So if you ever had a chance to watch that horrible movie, I like it because I used to be a salesman like that. That file, that attacker came in and stole that file and sold it to their competitors month after month after month after month. And what would happen was they would still take that file and load it up in for their sales people internally. And when those salespeople went there to go ahead and sell that list, the people had already been sold. So it demoralized their sales team, which they lost their entire sales team. They turned over their entire sales team in 6 months twice. They had like 15, 20 salespeople. Turned it over twice. It eventually drowned the company. We caught it at the tail end and did a forensic analysis. Zero text exploit. Have you ran into one of these in your career? Is that the stuff for phones, TR? Is that what you're talking about? I think that's the stuff for phones. And if it is, then no, I haven't. I know about it. I read about it, but no. So yeah, it's one of the links that I have earlier. But when you look at these exploits, they're going after these custom web applications, and you have to look much wider and much deeper. And here's the thing with custom web applications. The way it gets set up in the scope of work is you say, okay, I'm going to test the web application. Usually what they'll do is they'll give you the whole web application, and they'll do what's called a white box test, where you know everything. If they don't do a white box test, they step back from that and they say, okay, here's a copy of the application. You can't look at the code for it, but what we'll do is we'll give you a user account and see if you can escalate your privilege to the next level. We'll give you an admin account and see what you can do. And we'll give you each one of the levels of accounts and see if you can break the logic and get to access features and resources that you shouldn't be able to do. One of the things that I would do is anytime that I'm allowed to install an avatar as a user or as an administrator, I definitely try to take something that's supposed to be a JPEG and put it in there and let it see if it actually parses it. By the way, the solution to this problem is one of two things. You can turn into avatars as a service, which is exactly what WordPress did. I thought that was pretty brilliant. Or any pictures that are ever submitted, you crop them. All you have to do is crop one side, one edge of the pixels off of each side of them, automatically do that cropping. And then if it's a real image, it'll crop and it'll work. If it's a fake image, it won't crop, it'll crumble, and you can toss it aside. Now, you should be doing some other kinds of scanning on it, but that's just kind of like two simple ways to solve that problem. It's ultimately a privilege escalation and a privilege abuse thing that you're trying to figure out. From a core term standpoint, you've got to know your OWASP top 10s. The other level to this is what's called the well-known attack patterns. And I wanted to bring this up because this is still a part of CAPEC. And this list right here, put this into the attendee chat. This list right here is almost exactly the same as OWASP. Take this list here, take the OWASP top 10 and merge them together. And you will have 3 more attacks than will be on your exam that are possible. Now, what's really beautiful about CAPEC and why I asked you to go here is let's look at cross-site request forgery. Just look at that one. They give you a description of it that goes onto a note card. They show you what the execution flow should look like. They give you a decent link that, as an example. They tell you how you would do the actual exploit against this, the different techniques for convincing the user to click, which then they also relate to and point to the phishing. They tell you about your resource requirements, the consequences of it, mitigations, but then here's the really beautiful thing. They give you a decent example of this. Here's what happens for your exam. They can't give you full code examples on your exam. They can give you pieces of code examples on your exam. Those pieces have to be clearly going after something. Like, for instance, if I typed in, here, I'll do this for you all right now. This will get you one more thing right for your exam. You're inside of your machine at the command prompt. Tell me how you go up 2 levels with one command. Type it into the attendee chat right now. Tell me how you go up 2 directory levels with one command. Let's see what you get. You're right. What's that? Anybody know what that is? That's base 64 encoded this. So for your exam, they can't make you do base 64 decoding. They can't. It's the EC Council's CEH is a lower level exam. By the way, for the OCSP, is that right? OCSP. For that exam, they do make you recognize base 64 encoding. So when they give you an example on your exam, they can't base 64 encode it, and they have to make it generic enough so that you can understand it. You with me? And so if you read the example instance and any of the details, so it's example instance, mitigations, very thin, exploit and how to get it done, techniques. Like, they can't make you base 64 encode this. Your brain would break. So these generic examples that you have here inside of CAPEC and the descriptions that are there for each one of the ones that I've given you should satisfy all of the requirements for the exam. You'll know as much or more than the exam. But you don't have to learn how to base 64 encode. And when you see stuff like what I typed into the attendee chat, that doesn't work. But I'll just let you know that this CD ... That's called directory traversal. Are you allowed, when you're on the web server, are you allowed to go back up through the chain, go outside of the web root into the actual operating system's hard drive where other tools are available. And if you're allowed to do that, then you're allowed to execute those commands that are present on that operating system. Well, that's the rainforest puppy attack. So they have to spell it out for you. You have to know that from your attendee chat that that is directory traversal and that they can't make you encode it. Where all the great examples are right here. They're kind of perfect. There is one other place that you can go to look for this stuff. And so that's kind of like the gem for the exam, but it's also a very clear understanding of each one of these for you to be able to start learning how to attack. And if this stuff resonates with you, then you're great. You're in the right place. Okay, so now let's talk pure techniques. So when we look at techniques here, it's a little bit different. This is the actual methodology and practice, if you will. We footprint the web infrastructure, which usually means site mirroring. We analyze the web application, bypass the client-side controls with a proxy server. We figure out what the authorization schemes are. You figured out those on the expsec.us site if you logged in as the different users. You detail and document all that stuff out. Then authorization first. Access control is the thing that I just described. Authorization schemas. Are they using 1-factor, 2-factor, or 8-factor? What are they doing there? And once you figured out the access controls, then you figure out any kind of application logic flaws. It's kind of like the perfect encapsulation of that. So from a footprinting standpoint, you're doing server discovery, then service discovery. For your web server, it should be an administrative interface that is not available to you, that is only available to their internal IP addresses, well understood. Personally, from a defender standpoint, if I was doing this as an administrator, I would be using, what we use in class, which is I'd be using guacamole if I had to. Because then what you've done is you've said, here's my guacamole instance. It's the only thing that can talk to these web servers. And on the outside of this, these are the only IP addresses that can talk to my guacamole server, so that I can go ahead and add and subtract them. But then inside of that, I can attach this to any authorization scheme that I want to set up. I can set up full-blown SSH certificates back and forth between SSH certificates back and forth. I can do multi-factor authentication. I can integrate with AD, but people aren't doing that nearly as much as they should, because then the service discovery, it would go away. Server identification, we got most of this from a banner grab. Hidden content discovery. It's happening less these days with current websites, and if there's already been one penetration tester through the door, then those are gone. But the Wayback Machine, the previous version, is still sitting up there at the Internet Archive. You can go back in and you can look at that website and see what the old hidden content was. Still valid and available to you. In analyzing the web application, you're looking for entry points. Entry points are very simply dialog boxes that you can insert stuff into. What is the data that can be put in this box? I would say personally, never, ever, ever allow anybody to put in any more than 254 characters. Ever. I would make it less than that. And they would be characters. I would never let anybody upload an image, a picture, or anything like that. I would be horrible at Instagram. In Instagram, that or Pinterest, that's what they do. It's all pictures. But when we look at identifying entry points, what are the input boxes? And then how do we protect those? Identify the server-side technologies that they're using. So in my case, that one site that we were looking at was active server pages. Identify the server-side functionality. What is enabled, what is disabled, and then map all of that attack surface. Now we step off and we go into client-side controls. From our previous section where we did the reconnaissance, we'll know all of the different clients that are acceptable and all of the different browser versions that are acceptable. And we should test against each one of those to see if they get something that they shouldn't get. In this case, those clients will have hidden form fields, which then we're going to look inside of those form fields and see what's being passed back and see if we can adjust that. Pre-filled information that the client shouldn't have to do. We can look for any kind of browser extensions. Those holes have been plugged up on the Chrome side of the house, and pretty good on Firefox, but I don't know about the rest of them. Do we have access to the source code? This is a yes or no question. If the answer is yes, you're doing a white box test. Now you can start using other tools for your source code review. You can do your static analysis. You can do your dynamic, you do your static analysis right away with a bunch of different tools that are available to you. By the way, anything that's on Google's website that they have posted or that they allow to be posted is completely void of cross-site scripting capability. You cannot cross-site script against them. They eliminated cross-site scripting and cross-site scripting, and then the other one that I can't think of. I can't get it out of my head right now. They eliminated them 3 years ago, and you cannot do them against their sites. I don't know about JavaScript for sure, but for Google. I have a friend that's an internal security person there. And the checks that they make on any kind of code that is released has eliminated the cross-site scripting and cross-site, damn, now I can't think of the other one. Okay, authorization schemes. So we're only looking at input fields that are going to be used for authentication mechanisms. The next level of this we talked about previously, which are tokens and cookies. We talked about it yesterday. So user IDs, usernames, these are going to be the first piece that's going to be passed. Are they taking these pieces right here and converting them directly into tokens? A classic thing that happened for a long time, I haven't seen it in a while, is taking the password and base 64 encoding the password and sending the password back over and over. Yes, thank you, DK. I could not get it out. Cross-site request forgery. I couldn't get the term out of my head. But all these fields used to be converted into like base 64 encoding, or, and here's the new thing, was a token that represents that user ID that didn't change the next time that user logged in. So an encrypted token that is changing on a continual basis. So like if you got that user ID and it was converted into a user ID or like a really long string, you could take that string and reapply it the next time, and that would be in your not session hijacking, but it would be your ability to go ahead and do session replay at that point. So all these fields now become suspect, and you see what the outputs of these fields are. So that's the authorization scheme and how they're doing that. What is the token tool that they're using? Now for access controls, what can they get to? What can they do? Where are the read fields? Where are the write fields? Where are the read and write fields? Where are the execute fields? And how are these portrayed? What are the levels of access that you're granting? And the administrator functionality to configure and monitor. So this piece is separate from. That was where, when I talked to you about that website that I went into with the 60,000 administrators and the millions of users, that's where they made their mistake. The administrator functionality to configure and monitor, the website, it was only supposed to be allowed for this one tool to read those 3 files and pull that data out and then give it to people in a separate box. It happened to be that that tool in its installation used a previous account concept to apply to not only those administrators, those 60,000 administrators, but to this particular tool right here. So it's not a reuse of permissions, but it's a same role for a different purpose. Privilege escalation is what it boils down to. All of these things, what we're looking for in everything for access control is privilege escalation. That's what we're shooting for over and over and over again. Last is the application logic flaws. Again, I'm not a programmer. I don't play one on TV, so I don't know what application logic flaws look like in most cases. I defer to the greatness of Sunny. Okay. Web developers are going to make false assumptions. They're going to think that in the case of the people who had the file that was dropped into that folder that was all the new customers, the customer sales list that they were going to put in, the false assumption was that nobody would be able to gain access to that location on the server and those files. It turned out that it was very easy to do that by jumping through a couple of little hoops. What is my master password? Are you trying to fish me, MW? Or are you making a comment on what we're doing here? Yeah. Okay. Controls. Now, you'll notice that this is in the wrong place, and this is by design. So this isn't the SQL section. This is the web application section. But I put this here on purpose, and here's the problem that we run into. EC Counsel, in certain instances, says the setup. You have this particular problem. You've seen evidence of this, 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 this. And they don't say SQL injection, but they tell you these are components. This is an example of SQL injection, but they say it this way. The customer asks you what you should be doing, what we should be doing as far as securing these environments is concerned, and your suggestions are weak crap that doesn't work. Here's that weak crap that doesn't work that you have to memorize as a response to that. Limit the length of user input. Okay, I said 255, but I just said no pictures. Use custom error messages. Yeah, that's all built into the applications by default. Web application firewall. You would think that would be something that's done all the time, but it's not. I mean, look, for $60 a year, anybody that's running WordPress can have a web, now it's $99 a year. You can have a web application firewall that will protect you from most things and stop you from doing stupid stuff. And it will monitor for when you start to do stupid stuff. Monitor database traffic using IDS and web application firewall. Really hard to do. You have to have custom built IDSs to do that. Disables commands like XP command shell. That's built into the Microsoft application itself. It is disabled by default. A lot of administrators enable it. Isolate the database server and the web server. If you could have, you would have done it already. Run the database service account with minimal rights. So what you're saying is your service account is allowed to do everything, but we're going to go ahead and trim that down to just these particular activities. If you could have done that, you would have done that, and it would have been built into the operating system. Move extended stored procedures to an isolated server. This is the first one that I thought was great. Extended stored procedures let you get into all sorts of stuff. I don't know what, I've heard of Zabbix, but I don't know what it does. Validate and sanitize user inputs passed to the database. This is the worst advice because you do want to sanitize user inputs passed to the database. However, if you're looking for this, or you're looking for this, could you be looking for that? I know, I messed it up. Zabbix. I have to look that up. More homework from ECT? Software monitoring. Yeah, I'm not familiar with it. Okay. See, the problem is with validating and sanitizing user input passed to the database. This is what Rainforest Puppy said. He said to Microsoft, stop doing directory traversal, stop allowing directory traversal to occur. And I can write ... as anything I want to. I can make the SQL server do math for me, which we'll see in the next section. So this is a wonderful thing, but it does not work. And a lot of the things that are here are either already in place, and if you say those to your customer, the customer is going to look at you like you're a complete moron. I've had that look before, looked at me, because again, I'm not an application developer. And I said, do you validate and sanitize all the user input? Do you parameterize all your queries? And they go, the system does that. We don't do any of that stuff. And so they just looked at me like I was an idiot. And I asked the question, but my revenge on them was, well, obviously you didn't do it because you're hacked, is what I wanted to say to them, but you can't say that. That's career limiting. You won't be invited back. So this list that's here is something that you have to memorize to parrot back for EC Council, but don't do it to your customers, okay? The best place to go to get advice would be in the OWASP security area. Come to my CISSP class. I'll talk to you all about the OWASP security hardening guidelines and the checklist that they have there beyond the scope of this course. That's the basics of web applications. And now I want to step over into the web application tools before we take a break. When we come back, I'm going to do some demos on web application hacking for us. For a setup, you need scannable web servers. You can try MovieScope. You don't have the rights to it. But one that is allowed on the outside from a scannable standpoint is certifiedhacker.com if it's still up. EC Council gives you the ability to scan the server. They refresh this server over and over and over again, which is kind of amazing that they do that. Build your own hackable servers. Damn vulnerable web application. This is the SourceForge one, BWA. Which has a whole list. What's cool about this one is it has a whole list of vulnerabilities that are on it. WebGoat, best, hands down. We're going to open up WebGoat and talk about that one in just a sec. This is a really old thing, okay? So a lot of things have not changed on this for a long time. Deliberately insecure web application. We're going to come back to that in a second. It is a great thing. And then there's a whole list of others that I came up with. This was Geek Flare. I found this, and they talked about, and you're going to get a lot of repeats here. And by the way, BWA is buggy web application, and so they gave you those things there. So that's, you have to build the hackable web servers, build the ones that are already mucked up. I would go through how to set up WordPress on Ubuntu, and I would also how to set up the Windows servers that are out there. I gave you 2 guides on how to do those. Those are from hacking articles. We talked about the gentleman that runs that site previously. So you've got to have some sites. From an exam standpoint, one tool, Weavely, 20 minutes. Very, very simple. Use that tool. Do you have to use the other tools? Yes, because and when we do WebGoat, all the different vulnerabilities for OWASP are listed there, and you have to know how to hack those things a little bit. You just have to go through the lessons for WebGoat. If you are actually looking inside of my GitHub for CEH Bootcamp, So you will see that 14, okay? This is your full practice using WebGoat and WebWolf. When I had the original machine, and this is where we're in this crossover period, so I don't know which one will work for you and which one doesn't. If you're using the old build, if you built up your Kaylee lab before this week, like you did it on, anytime before Monday, and you used the old process, there were some problems getting WebGoat to run. It just barfed and hiccuped a whole bunch of times. And so what I did was I bulletproofed that process here for that instance of Kaylee. I don't know if the default JRE and the default JDK for the 2024 instance of Kaylee have been fixed. But if you start running into problems, come and look at this 11-step process that's here, so that what you can do is you can run WebGoat on top of Kaylee. You can run it separately, and again, you can look at the project from here. And I wish you very well for all of those things as far as the WebGoat is concerned. I think you should do it this way, but some people don't want to do that. They don't want to do their Docker images. They want to do the live stuff. And so therefore, if you decide to do that on your Kaylee instance, you might have problems. And I worked through each one of those problems. Once you've done that, you're ready to go. What's beautiful about every one of the failures in this web server is it'll give you a step-by-step, and there's a series of videos on YouTube that will walk you through each one of the WebGoat failures. It'll show you what to do and how to do it, and then you can go and replicate that inside of your own WebGoat for yourself, and you will have done at least do the first 6 or 7 in the list to know how they work. If you've done all of them, there is nothing that they can ask you on the exam that you don't know the answer to when it comes to OWASP. Just by doing it once. You don't have to be perfect at it. You don't have to understand it. You don't have to write up all the lab stuff that I talk about in the other labs. You can just do it once and you're golden there. The beautiful thing is that I'm not a programmer. I've done the OWASP, and at least I know that this is a web application or a web server problem or an SQL problem that I can then turn to somebody else with good documentation and say, I think this is an SQL problem, and here's what I found, and here's what I went through. And so I can actually do those tests there. That's the basics of all web servers that are out there for us. That's web applications, and that takes care of that. And we're going to do SQL injections in a little bit. When we come back from our break, I'm going to do a couple of demonstrations for you, and I'll take any and all questions. And then after we do those questions, I did that. We're going to skip over Burp Suite. And next will be the quiz questions. So I'm going to do a demonstration, and then we'll come back in and we'll do some quiz questions, and then we'll flip over to the last section. We have an hour and a half, a little less than an hour and a half left in this session. So I'll see you in a few. I'm mute for the break. How you doing? Hanging in there? Okay. We're going to do the exam level questions first. I'm going to give a little bit of time to think. Remember, these are set up on the 4 options, which is more like the real exam. With the quizzer for VMLT, it's definitely set up with the 4 options. On your exam, I talk much more detail in the CEH2 day about the exam types, the exam quiz questions, and those kinds of things, if you're interested in that. If you don't want to come to that 2-day, the recordings also talk about the different exam questions that are out there. The majority of the 90 exam questions that you're going to run into for the current version of the exam are 4 options with a question. There are a few 4 question, choose all that apply. So they'll give you like 6 or 8 things, and you have to pick the ones that are reasonable for this. You can't choose all of the above, and they may tell you choose 3 of 8, that kind of thing. And that's a really small subset of the questions, very few. And then there are a couple of kind of point and click kind of things that you have to do that are they're fake setups for real computers. And once you see them, you go, oh. In theory, you could skip those. Usually what they do, and this happens with a lot of the current exams, they'll give you something at the very beginning that is one of these interfaces that you have to work through and figure things out. It's there to scare you, distract you, and reset everything. So what you can do is you can go, I'm not doing this now. If you're allowed to go ahead and skip it and come back to it, there's some exams out there that don't allow you to skip it and come back to it. For the EC councils, from my experience, you can skip it and come back to it. So when you see those big overwhelming questions that are not 4 options and 1 list, mark it and come back to it and go do all the easy questions where you've got lots and lots of brain power, because it's well understood and well documented that people who go in and take tests, when they get further and further to the end of the test, they get more questions wrong. So go fast and get all you can and scoop up as many points as you can. And then where you were going to panic in that question, go back and panic and get that one wrong, but collect as many points as you possibly can. The goal here is to just get above the 71%. It's not to get a perfect score. When you saw my score at the very beginning, mine wasn't a perfect score. So that's what you're shooting for. Okay, exam level questions, here we go. What attack is described here? Exploiting a vulnerability in a dynamically generated web page to inject client-side script. You should have this down to a 50-50 coin flip right away. You've got 60 seconds. Okay. It is cross-site scripting. I don't want to give too much away for the other questions, but the key here is client side. Okay. Oh, That was the last one. I used to have another question in here, but the question was a little messed up, so I pulled it from the course. Client side is cross-site scripting, and then server side is cross-site request forgery going to another one. Yeah, well done, team. Yeah, everybody did really well there. Excellent. Okay. And we're not going to go do SQL injection yet. We've got some demonstrations that I want to share with you. Here, what we're going to use is we're going to use burp to brute force. It's burp suite. Now, before we go any further, if you ran screaming from the room, these are not this section. We're going to get into the SQL section, but I wanted to give it to you because there's some people that that they run before the top of the hour because they have something else to do. If you only do one set of labs for SQL injection, do the free ones at Portswigger. And so now I'm gonna come back to that, but I wanted to, because there's some people that like run away like in this portion of the discussion. Okay, so just I'll come back. I'll discuss everything about that, but I just didn't want you to miss that. Okay, so here we go. We've got a website here, and what we're doing is we're logging into that website. Now I'm going to go over to a Windows machine, and I'm going to log in as the administrator. And notice if you're squinting up there, you'll see that that's 10.10.10.16:8080. Normally it would be a standard website. But when we go into this website here, I'm going to log in as an end user at this moment in time. And now, instead of logging in, I've got that dialog box. This is what you cannot do against the expsec.us site. It's one of the things that I want to do in the future, but you want those dialog boxes and you want to intercept the information going to those dialog boxes. How do you do that? Well, what you do is you turn on a proxy server. The standard way to turn on a proxy server is to go into the settings of your server, your Firefox configuration on your client side, and set yourself up as a proxy server. And so that's exactly what I'm doing here. I'm defining that proxy server, and I have to know the configuration of the proxy server on my side to set the port number. But traditionally, it's at your it'll be something like your SOX host, and it'll be at 127.0.0.1. Traditionally, it's a SOX 5 host, and this port is like kind of a standard for most of them that are out there, but not all. So what I've done is I've set the manual proxy. And now what I'll do is I'll do my web application analysis. And here's where I do the community edition of Burp Suite. Now, when I do that community edition of Burp Suite, what happens is it's going to give me this little failure. This is the community edition, so it doesn't have all the tools inside of it. And you have to say, it's okay. Now, this should go away in the current version of Kaylee, but it depends on what you're set up with. So I just click OK there. And now what I'm going to do is I'm going to go in and I'm going to set, hang on one second. I'm going to agree to the terms and conditions. And then it's going to start me all with my Burp Suite, and I've got to set up my, you might want to do your update and then tell it not to show it again, after you've done that for a particular time. So in other words, don't keep on updating my suite for me, okay? So 1 week is like, that's fine. Next, when you're doing this over a long period of time, you don't do it all at once. You'll do it in like stages. You might come back to certain things. So you can set up template projects or regular projects that are out there, opening existing project. If you've got a lot of people working on your team, you might be handing off a project file, probably not for the community edition. So then I'm going to use all the defaults and I'm going to say start. And now we need to pause for a second. So look at what you have in front of you. At the top of the page, you've got your menu bar, burp, project, intruder, repeater. See, way up at the top. Then second level, you've got a bunch of different sheet tabs. Right now, we're sitting on the dashboard. The dashboard has 4 panes. Well, they're actually 2 panes, but it has 4 panes that you have to look at. Task in the corner. Then you've got your event log down here that it's generating. Issues and activities, and then advisories that pop up. When you click on things here, they populate down here. Okay, so what's going to happen next when we go through this is you're going to get another layer of tabs on top of tabs. And that is the thing that freaks people out. Is anybody here, if you've used burp before, throw me an exclamation point in the chat and say, and tell me whether this confused you or not. Because I mean, I drowned the first time that I was actually doing this. Anybody use burp? Okay. So now what I'm going to do is I'm going to set things up and get myself ready. I'm going to go to my proxies and I'm going to start up the interceptor. So by default, the interceptor is turned on. I've made this burp my interceptor for the interface for that WordPress site on my local machine. I'm going to go to the server. So every time that I go to the server, I'm going to hit the proxy server and it's going to intercept my request and look at what's going on. Okay. Yeah, the thing is with this, and I will tell you that Portswigger's education on this for the community edition is great. I can't think of any better way to actually do this. So I really kind of love it. Okay. So I turn the interceptor on, and now what I have to do is I have to go. I have to get some stuff. I have to get that activity. So I go over and I log in and I type in who cares what it is and who cares what it is. I'm going to type in admin with a password. I'm going to hit, well, I mucked it up. Okay, then I log in. Now, you'll notice it's asking for saving it. I say don't save. But now it stops. And you're like, it's broken. Well, no, the interceptor caught it. Okay? So now you have some options here. You want to see what's coming through. Now, this, by the way, is not what's coming through. You want to see what's coming through. You want to see if you want to manipulate that. And then you want to decide whether you want to forward it. So this is like a person in the middle kind of attack that's going on here. So I go up. Takes a sec. I'm going to send the sequence. I'm sorry, send to intruder. Now what happens is I go over to my proxy and my interceptor is on. And I say forward that request. Now we pause right here. Okay, look up inside of here. You'll see on this line right here, when I sent that message to the server, it captured all of the stuff that I was sending there. So I used the login, and it's called log, of admin. It highlights it in red. And then it says, you've got a password of password. Okay, now all the other stuff doesn't matter. Those are the 2 fields that I want to convert into variables, so then I can then pass my my brute forcing technique against it. This is, some people were asking me at the very beginning of the class, can we use, password guessers? And if you were going to use them against that site, this would be the tool that you would use. And I said no, because you have to capture this information some other way. Now, at that point, I highlight that line and I say, convert these into variables. And so what I do is I send it to the intruder. This takes a second. Now, what I want you to notice is I've gone over to the intruder, and now you can see up at the top of the screen, you can see intruder 1, 2, 3. That's one set of tabs. Then another set of tabs below that, target, position, payloads, and optimization. So you got 4 levels of menus here. Ah! Now, what I do there is I intercept, and when I intercepted, you'll notice that the login admin has now got these weird signs. I don't know what those signs are called, and I can't generate them on my keyboard. I've made Portswigger Lab, and I was fine with the sub menus after a while. Yeah, but the first time that you see these multiple menus, you freak out. So EH, you're right. Once you get used to it, but the first time you're like lost, especially if you're following somebody else's instructions and they say, go to the intruder third payloads folder. You're like, what? And so that's why I point this. That's why I'm doing this lab, is because that type of stuff, you really have to sit there and go, okay, now where do they want me to actually go? Because I've never done this before. But up above my brain here, let me get out of the way. You can see right here that I can say, okay, if it's not called login on that page, what is it called? Is it called authenticate? Because they decided that that field is going to have a different name. You would have gone to that page and chosen reveal codes, and it would have said authenticate equals, and then there would have been a hole there. But it's a lot easier in the proxy server to pass that request on and see what the server is sending. You know that you typed in, if the hidden field was authentication and the display field was username, and you keyed in, instead of admin, you keyed in some special code like Otto, O-T-T-O, you'll be able to find Otto in all of that text that's right there in front of you that's being revealed, because it's not going to be a nice, clean page like this. It's going to be lots of cascading style sheets. It's going to be lots of other garbage that's piled on top of this when you reveal codes. It usually cleans it up for you, but sometimes you'll get a flood of garbage in there. And so it was Otto, you keyed it in, and oh, Otto is my admin, and that says login, or it says some other weird name. You can reconvert Otto into this, and that's what those buttons are for right there, for those variables that are going to be put inside of your file. It doesn't have to just be username and password. It could be username, password, user ID, phone number, whatever it is, all those different components. You can add a variable for them. You have to prepare for those variables in the files that you're going to pass. So if you see phone number in there, you have to have all the phone number variables that are reasonable in here. If you see zip code, you have to have all the reasonable zip code variables that go along with this. Okay. So now what I do is, and this will be a little confusing because I'm going to go back and I'm going to overwrite these variables. So I remember I do the pinging there. That's just a side benefit to that. And what I do is I undo all of those. So notice what I did is I clicked the clear button up above my head. Sorry, it's a little out of frame. I clicked the clear button, and now I'm going to make sure I specifically reset each one of those. My attack type is going to be cluster bomb here. Okay. I'm going to add the variable in for the password for log, and then I'm going to do the same thing for password here. And all I'm doing is clicking the add button there, and it pops in, and now I've got it. I want to make sure that the variables that I'm passing are correct for this, because a lot of times what you will do is they'll give you a weird name for it. They won't call it password. By the way, AWS is classic at this. Okay. So now what I'm going to do is I'm going to put the payloads in for this, and I have to set the payload variables. How many payload variables do I have? Well, I've got username and password. If I had other fields, I'd have to go ahead and say these are how many variables that I have. Okay. So I can do the simple list, and now I have to load those lists inside. What am I loading inside of here? I'm loading inside of here my username list and my password list. So I've got to go find those inside of what I'm looking for. And in this case, I'm on a Unix machine, and I get my common list. There's my passwords and my user text. Now, I place all of these, all of those files, I always place them inside of sec list. I load, the first thing that I do is I load sec list in and populate my personal files inside of there. I actually have you do that in your lab. Okay, now, what it does is once I loaded those lists, it gives me that list inside of here. So those are all the potential logins that I have. Those are my payloads for my simple list at that point. And then I set my payload list to, notice I set my variable way up there, I set it to 2, and now I'm going to load the other list inside of there. It conveniently goes ahead and lets me go to that same place. So that's why it's really good in sec list to set up your passwords and your usernames in some form of the same area. You may not do that because you might be in a really big team. Why would you do this if you have login and password already? You wouldn't. If you've got login and password, you wouldn't. But suppose you're logged in, it says, give me your zip code as a secondary authentication so that you can get to your admin privileges. You know, the application might have other form fields that you have to fill in once you're already authenticated to do something else. You know, this happens with Amazon. Amazon asks you for extra things after you've logged in when you want to ship something to a different location. So you wouldn't. If you've got the username and password, you'd be good. Okay. Now it's going to give us some output. We want to look at the output here. So I'm capturing this traffic. And now what I do is I send it along. Now, before we go any further, it's going through this process here, and I paused it. Take a look down there. It says 8 of 117. But then in the status window right here, and I know that's kind of a squint-a-thon, it's giving you HTTP status messages. 200, 300, 400, 500. 500 are server errors. That means we broke the server if we get a 500 error. That can happen if you're being too aggressive. 400, usually that's, you know, some sort of file not found kind of mistake. 200, failed again. 300 is what we want, okay? So now what we're going to do is we're going to go to lunch. We leave, we go to lunch. I'm not paying any attention to this. I'm doing, let me go ahead and get my glass of water. I haven't looked at any of these things. Whirl, 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 and this thing goes on. Now, here's a little trick. You can sort by status message. So all those other things went away, but you've got these headers up at the top of the fields, and you can sort by status. What we want is a status of 302. A status of 302 means we successfully logged in. So you could do this for thousands and thousands of, and you don't care about the 200 results. That was a failed attempt. You went back and started over again. You want 302 results, you sort them to the top. Now you have usernames and passwords for this particular site. It might be that you have to key in other variables outside of that. We wanted to be able to do this purely from a web app standpoint. I personally would rather do Hydra, but see, you don't have the interceptor and all those kinds of things. And this one's built for doing just that. It's built for doing all that interception work that's right there. Okay. So once I've done that, now I go back in. I can turn off my proxy settings if I want to, and I can go straight at that machine and then resend those credentials, actually keying in that password. How would a user know he's being attacked like this? A user wouldn't know they're being, well, okay. If you were proxying the user, like you convinced them to key in their stuff, things would be really slow, because every time a user clicks on something and does a submit button and goes to the next page, what would happen is they would get that waiting for site. We'd have to catch that, look at that, and say, pass it on. So it would be, we would have to say, I'll have to find it here. I don't have it in here, but it would be a dialog box on our side of the proxy server that says, this is this information that's being transmitted. Do you want to pass that information? So we're intruding on it. We're looking at it and we say yes. In theory, you set up that proxy server, you deliver that to an end user, and then what you're doing is you're actively watching this. So when that happens, you send this thing through. You can socially engineer the user by responding to them and sending them back messages like, we're having trouble with the website today. It's a little bit slower than normal. Please stand by with us while we upgrade our security. You can send that message back to them if you want to, but you have to have that pre-prepared. And then, so then the next thing is the user types in their username and password, and you catch it. You've already caught it, and you send it on real quick. So you just keep on hitting transmit, transmit, transmit. But remember, the messages are also coming back from the server. So you're transmitting to the server, and then you're receiving from the server, and you're transmitting back to the user. So you're managing the connection on both sides. You got to be quick on the spot. There are tools that will do this for you. So, and remember, this is the community edition. There are some other tools out there that you can lay on top of Burp Suite and separate from Burp Suite, like NetSparker's got one, I think, or they used to, where it would send those messages back and forth and de-encrypt them. Because when the proxy server catches the message, it's encrypted from you, the victim, to the attacker, and then we re-encrypt it from us to the server. And so we go back out that way. And so now I've created a secure connection with me and the server, secure connection with you, and then inside I can see everything going on. Maybe that was a little bit more than you wanted to know there. Okay. And this is primarily not for attacking. I'll say that too. Okay. Now let's look at parameter tampering. So now, how would one protect themselves from something like this? I would, if I didn't know the network and I didn't know the host, I would use my, first off, I would use my own device. That would be tops on my list. And then after I use my own device, I would use a VPN from my device to a secure point. So, and you'll, like a lot of my advice from my clients, from my virtual CISO stuff, I tell them never use an open wireless access point. Always use their phone for tethering, and always use their phone with a VPN on it. And then that would stop a lot of that stuff. But if I'm able to send you a proxy configuration file and convince you to click on it, you've lost. And most of the time after that stage, you wouldn't see the pausing back and forth, because the automated tools would do this so fast that it looks like the internet's having a slow day. And that's all it looks like. So I think that helps. Okay, so now what we're gonna do is we're gonna look at parameter tampering, and this is a little bit different. So now what I'm doing is I'm going to Movie Scope, and who am I logged in as here? I actually have a login. So remember before I talked to you about escalating privileges, and somebody says, here's your account on this server. You go, okay, thanks for my account on this server. I really appreciate it. Or you could self-sign up, or like with Amazon, as long as you've got a credit card, you can have an account on their system. Now, once I'm on the system and I have that account, how can I abuse that? So I start off by logging in as a valid user. Still using the proxy server here. Same thing is set up. I'm catching all of that stuff, but I'm looking for other components here. So I go in and I log in as Sam. Valid account. Everything's good. No problem whatsoever. But I capture that information. Okay. Now, here I've saved my password, my username and password, and that's fine. It doesn't really matter. You can say do not save. And I forwarded the request on to the server. And there's my login. And if you look at this, it's unencrypted. That's not really fair. Most of the time it's encrypted. Okay. And that gives you the username and password. We don't care about that because we've got a secure connection and we have a valid username there. So you can see that we've got a username and password and a login right there, and that's okay. We're on that page. Now, when I click the login button here, now I'm going to be onto the site with Sam's credentials because I was allowed to have Sam's credentials, and that's perfectly reasonable for me to do. I forward that on. I sit inside of the server. And now I get a cookie. I'm going to need the cookie. It's going to be important. So I get the username. I log in. Takes me a second. Hang on a second. Now, I'm in as Sam, and I'm going to view my profile. There's that cookie again. No problems, right? At the top here, I know it's a little squint-a-thon. View profile, ASPX ID equals 1. I'm Sam. My profile is 1. Can I change it to 2? And that's what we figure out here. What we do is we capture, use that cookie for ourselves, and I've got the cookie and I fill it in, and my ID is set up to 1. Now this is in, by the way, this is in the parameter sheet at this moment in time. And now I'm doing a parameter tamper. So I leave the same cookie, correct cookie, but now what happens when I change that value to 2? And then I transmit that data back. Turn the intercept off, pass it over. Now that value lets me see I was Sam, and now I can see John's profile. You go, Dean, this would never happen. We would never be able to do this. With a little bit more encryption on top of this, this happens a lot. More than you would imagine. Because they think that you're a trusted insider at this point, so crossing over and using that inappropriate cookie, that should never happen. They should have 1 cookie per user per session, and they should never be reused. And they shouldn't cross any kind of boundaries. We should have, from a defender standpoint, we should have said, different cookie, different user. Sorry, you can't go ahead and do that. But we crossed that boundary and we got in just by doing that one thing right there. And so we're in as John by doing parameter tampering. It's a little more complicated than this today, but not much more complicated than this. And so we want to see how long those cookies are valid for and whether those cookies allow us to cross accounts. Because remember, the cookie is nothing more than an authentication mechanism for the session information that's being transmitted back and forth. Okay. I'm going to leave this one here. This is going to be the last thing that we're going to have time for. We've got 45 minutes left in this session. We're going to come back over here. We're not going to talk about SQL injection just yet. Talked about web applications. We took care of that. We took care of the tools there. We took care of WebGoat. Now, inside of WebGoat, one of the other functions that's inside of WebGoat happens to be SQL injection. So if you don't want to do the full-blown SQL injection, you can get a lot out of this. Now, what I want to point to is in the wiki. Let's see if I make sure I get this right. Right here, right above my head, it says exploits and solutions. Okay. So they give you each one of the lessons, the proxy server, the SQL injection, and you'll see here that they've got SQL injection lessons here. So you can stay inside of here and do your SQL injections inside of WebGoat, and they'll work out just fine. Be a little bit more, okay? That's usually what I say here. Let's see. Okay. I think that takes care of that. So we're not talking about that anymore. We're going to talk about SQL injection and our tools and tester success page. I think we took care of that. Okay, so we're going to come back to that. This is going to bring us to our last break. Yeah, that's about right. We're at 3:16. We're gonna take a 5-minute break, and when we come back, we're gonna talk about SQL injection, and I'll leave the questions. I'll leave the question set up so you can type in any questions that you want at that point. So yeah, 5-minute break. I got a little ahead of myself there. We went a little faster than normal. 5-minute break. I'll see you back here. Run away, go play for our last bit of the session. We will finish right on time today. Okay. Now, you've been warned, but I'm going to walk you through it. Remember, this is costing you somewhere between $1 and $2 per hour to run. Depends on certain variables. If you finish with the lab for the day, you can check it off and say instant state. Now, the problem is one of them's already stopped, so I have to deselect that one. And now I can say instant state, stop instances. I say, are you sure you want to do that? I go, absolutely. So now they're in the stopping state. At this moment in time, I am paying for the storage of these images here and the storage of the images there. Paying double for storage. I go over to Cloud Formation. I find my stack. Now, by the way, that this one says rollback complete, and it's fine, it's gone. I choose this and I say delete, and I delete my stack. Now, that's going to take a while for that to do that. It takes about 2 or 3 minutes for it to do that. If you left your machines running and you said delete stack, it takes even longer than that because it gracefully shuts them down. And all I did was just crush them, okay? Eventually, what will happen is your delete message will go away, that it's inside of here. Your create, it'll say, delete complete, not rollback complete. That'll be finished off there. You can tell that it's doing the right thing because when you look inside of your instances, not instances running, but instances, now what you see is, now it says under there, terminated. And so that's the Cloud Formation going in there and wiping these things out. I'm no longer paying for the storage here. As soon as these machines go away, I am paying for the storage of these. But here's the cool thing. This, for the 4 images, is going to cost you about $2 a month. You go, Dean, I'm done with you. I hate this. I don't want to do this anymore. Fine. Then you choose each one of those images right there. And you go action, deregister. Now, completely stops ticking. And you know that you can go back to my site and you can build up all the images all over again if you want to. You go, well, Dean, I kind of want to do my lab a little bit later on. It's probably going to be a little bit later on this week. You already have your instance names and your AMI IDs already locally. So if we go over and look at the GitHub, you might need your SSH key pair. That might be, but you've already got one. It's already been created and you've copied it locally. So you haven't deleted that. The key pair stays there. Doesn't cost you anything to store a key pair. You don't have to do any of the copying. It's already been done at this point. So none of that stuff is important. And it says, each command output, your image is not the original. You need to copy these 4 names and image IDs. Well, that's right there. But you got to remember where it is. It's sitting inside of images, AIMs. That's where that's sitting. You log in, you download this file, you figure out the configuration parameters that you're going to drop in there. You check your public IP address to see that it hasn't changed by your internet service provider. You make sure that you've got your SSH key pair. If you're going to identify an old key pair, if you get in real trouble, like you're in the middle of something and something's really, really wrong, if you have an SSH key pair, I might be able to help you get out of it if you're willing to change things. But that's like really, really, oh crap. I've only had to use that once for like 900 students. It was bad. it does all the other stuff for you. It whirl takes care of it. So all you're doing is you're keying in, you're going to the deployment guide and logging in right there, and you're pulling down all that information. The cool thing is, in the future, what will happen is there will be no copying anymore. There will be, I'll have a file that has all of, it'll look at what region you're in. That's that YAML file. It'll look at your region and it'll pull your images down for you and it'll copy them here. And so you won't have to do any of the configuration file stuff. Well, you have to do one thing on the configuration file, but you won't have to do any of the copying. But remember, you're being charged when these are sitting in here, but it's only $1 a month. Okay. So I wanted to point that out to you. Now, if I go back in and look at my cloud formation, now that's a dead pen test. I don't have any choice in that one right there. I will get rid of that one, but you can see the other one's gone. I look inside of EC2. I look at my instances. It says terminated. They'll take a while to fall out of here, but you're not being charged after termination, not being charged for anything. Okay, so I just wanted to make sure that you tear down your lab because it does cost money. Okay. Without rebuilding, how do you change your public IP if it changes, or do you need to? SM, I won't answer your question. You would go into, you shouldn't be doing this. The easiest way to do it is to just rebuild. But what you would do is you would go into security groups. Your security groups that you have, okay, you're not going to see it right here because it's already been deleted out of there. These are all garbage for me. The security group would have the name right here on the name thing. It would be whatever you keyed in, like pen test and the date, which is what I tell everybody to do. And then you would go in there and you would adjust that you would adjust that security group, the one that says guacamole. You would go in and you would adjust that one to your new IP address. I wouldn't do that. It's faster just to rip it all down and start over again. I will tell you, it's too error prone to do this unless you're a cloud person. Okay. So there's your lab. You can have it anytime that you want to, as if Heidi said, Dean is awful, we don't want him ever again, he can never come back, my GitHub is going to be there for a really long time. So you can do that. Okay. So I don't, Heidi, is that at my job? Am I still secure in my job today? I should be okay. She's going teaching. Yeah.
Promise.
Yeah. No promises, but you keep on going the way you're going, we'll be okay. But even if that happened, you'd still be able to get to all of this stuff right here. You'd still be able to, even when I change the labs over, you'll still be able to get to all of these pieces. And so it's all there. And that's the cool part. Okay. I wanted to make sure that you understood that that's where you're getting charged money. Okay. Oh, thank God my job's safe. At least until I have at 30 minutes. Don't blow it for the next 30 minutes, right? Okay. So I want to talk SQL injection tools for a second and two different things, and then we're going to go do the SQL discussion. From an exam standpoint, there's only one tool, SQL map. I'm going to do a demonstration of it. You only need an hour on the tool. Not exam, but this is where I got my exam. This is where I got my presentation information. This is called SQL injection pwnage. It's one line pwnage that's out there. Okay. You install this in your Kali instance, and then it shows you how to do one line pwnage. This is SQL pwnage, and you can watch the video right there. Very, very cool tool that's out there. And I put that in the tools section. It's not exam. You have to do SQL map. On the professional side of things, there are so many different ones out there. This is not spending money. What I would say is dig into GitHub. The last time that I checked, here, we're going to look today, there are 6,000 results for SQL injection, SQL map. Look and be careful. By the way, any of these ones that you see inside of here, make sure that it's well understood that it's got lots of Ks and it's got lots of stars inside of it, like thousands of stars inside of it. Otherwise, be careful, because there's some new stuff that's going out inside of GitHub that's malware in and of itself. Don't load it on your local machine. Load it inside of Kali, and you'll be just fine. And if it blows up there, you just delete the machine and you start over again. Woohoo, you're done. That kind of thing. If you're going to do real penetration tests after your lab, and you're going to do them up there, and you're going to use these tools right here, remember, any tool that you use against your client could be compromised, so you want to check that out, test that tool as best you possibly can. There's advanced SQL injectors and all sorts of really incredible stuff here. So as far as it's concerned, go through the advanced search. Now, what you could do is you could go into exploit DB. This is separate. I've talked a little bit about this, and I can go into the search dialog box above my head. And so right now, what's my list? So I have 8877 entries for SQL injection. Now, we did not talk about this tool, but I wanted to talk about exploit database, the D, the A, and the V. The D is downloadable exploit. So you can click this download button and it will give it to you. The V is verified by somebody else. These are not verified by anybody else. The A, vulnerable application. Very rarely will you get that column filled in where they'll give you the vulnerable application so that you can load it up, test it, and actually run the exploit against it. They tell you what platform it's against, what type it's against. So when it comes to SQL, you can go and look at the tools, or you can just come right here and you can look in the exploit database, and it'll give you most of what you need right here. But again, this is not exam stuff. Exam stuff is SQL map and you're done. Real world, by the way, when I do it, even if I'm not doing the SQL portion of it, even if I'm doing the SQL injection or any of that stuff, and I'm handing it off to somebody else, I go in here and I look up. Now I've done my reconnaissance. I know what kind of app it is, what kind of platform it's on, all those things. I go and I look inside of here and see if I can find an exploit that's available. Yes, I will go look at the CVE identifiers to see if one's there, but that only tells me that it's vulnerable. This tells me I have some code that I can deploy to it. And so that's what's really nice about this. And so I gather this stuff up and I hand it off to my web application penetration tester in that case. Okay. So that's a little bit different than I've talked about in the previous past when we're dealing with tools. Okay. SQL injection. It really shouldn't be called SQL injection, but that's what EC Council's called it. That's what everybody calls it. It's command injection. How it happens is data is part of the string that is executed as a command by the application. Normally, when you hand me something, you're a client, I'm a web server, and I receive this, I don't trust you. Okay? And that's normal. But when I hand this back to my web server back there, what about the web server? The web server trusts me. And so it'll take whatever I give it, hand it back there, and it will execute it. Then it will go, you're a pretty good guy, Dean. I'll go ahead and take anything you want to them. What happens is when you transmit to me, I have this wrapper program that's set up, that's ready to go, that takes it on. The wrapper portion of this really is me taking the code on my side. And the reason why this works is another one of those layering and abstraction issues, where what happens is it gets passed back to the web application. The web application says, I just want to reconstitute this as an SQL query and pass it back there. And what happens is that field that's supposed to be password has been messed with. It is a failure to neutralize the special elements that's being sent to a downstream component, me as the web server handing it to the SQL server behind me. Is it really due to bad design? Well, the problem is that the software constructs these commands, but it can be externally influenced, and that's what we've done. What is the impact on this? Some form of unintended privilege, some form of database reveal is really what we're doing. It could be the database element inside of there is your social security number. It could be your credit card information. So it's revealing it to somebody that shouldn't have it. So we're in the exploitation, we're down inside of that. We're going to perform these malicious activities, and we're doing SQL injection. And that's really where we are in the exploitation. And then here are the core things that we have to talk about. Now, you're going to notice that I talk about the types in here, and I'm going to explain where I got that from a little bit later on. I am not a database guru by any stretch of the imagination. I can hang on by a thread when the database architects and developers are talking about things, but I'm looking at it going, no, I don't know what you're talking about. Okay, so I can tell it to you, I can help you get there and get you to the level of the exam, but please don't ask me really complicated SQL questions because I barely understand them. Okay, SQL injection. User controllable inputs. How? We start off with a conditional statement that's true. When the sun is shining is not always true. And also, an SQL database can't evaluate that. Now, the classic conditional statement setup is always true. It always evaluates to true. And the database goes, this is evaluated to true. Then do the next statement. So if then, right? Now, normally what you will see is you will see somebody saying where 1 is equal to 1. I know what you're thinking. What we're going to do inside of our database is we're going to look for, in quotes, we're going to look for this, and we're going to test for that condition, input validation, and we're going to stop this garbage right away. Got it? Where 1 is less than 2. Where 1 plus 2 is less than 4. And I can make you do all kinds of complicated math. What are SQL databases good at doing? Evaluating commands, especially multi-condition commands, like select where this is true, this and this and this and this, where the first name is Dean, the last name is Bushmiller, where the address is 1801 East 51st Street, and the zip code, and we can keep on making it do that. And so SQL, it'll keep on evaluating these conditions, and we can't plan for all the different ways that this can be said. And don't forget, we don't have to use 1 and 2. We can do the base 64 encoding of that if we want to, and make you do half base 64 encoding and half not base 64 encoding. So we can always get the conditional statement to be true. That's the first thing that you have to understand. And then do the next statement. And that's where we're going to start stepping in. The other piece to this is the SQL statement is built. Where is it built? It's built on the web server. Does the web server know anything about the SQL statements? No. Okay? It doesn't. But they're built there, or they're constructed because some of that information, the data field, is passed into this section on the back side. So if we want to break that statement, what we do is either we use the double quote or the single quote. We add that evaluation requirement where 1 is equal to 1, which is true, and we're ready to go. That's it. And normally what you do, old school, to test for this was you look for the password field and you throw a single quote in there and see what happens. But they figured that stuff out, so we have to go a little bit a deeper level here. There are 3 kinds of SQL injection attacks. And then I've organized them by vendor. So everybody type into the attendee chat, which database do you know about more than just knowing its name? Me, I know MySQL. I used to know MS SQL. Anybody else? Anybody got other databases that they know about beyond the name? Like you've written a query once. If nothing, throw me a question mark. Postgres, yeah, okay, MySQL or Maria, yeah, okay. H2, I don't know H2. H2. H2 database engine. Oh, okay. New for me. SQLite, yep, and MySQL. Okay, so anybody heard of PSQL? Does anybody know what PSQL is? ClickHouse. Oh, I don't know that one either. PSQL is Oracle. So you have to be an expert. Yeah, you have to be an expert in PSQL if you want to attack Oracle databases. Well, older Oracle databases. The syntax on these databases is a little bit different, and certain vendors are susceptible to certain kinds of attacks. And that's why I've organized by vendor. I would like to put vendor out by types, but I put it in here so that we can understand. The first type of attack that we are interested in, that we care about, is in-band. This is the same communication channel to perform the attack to retrieve the results. This is usually your web server being able to parse it. No, and they are not all the same. See, that's the problem. So within in-band, what are the different types? Error-based SQL injection. You don't respond to me, but you give me an error that gives me information. I set up, I don't want to go ahead and do that. So what I do is I take a system stored procedure, I put it on the back end of my database, and I say, this is called parameterization. In my system stored procedure, I'm going to execute based upon these conditions. If you can recreate those conditions on the outside and bring them here, you can trigger this stored procedure. There are built-in stored procedures that you can attack. Basically, it's kind of like what used to be called port knocking. Illegal or logically incorrect queries. So that logic fires off a particular activity. What's the next message? No SQL is even more different. It's for flat files, right? I'm pretty sure MC. Okay. Then what I can do is I can have union SQL injections where I join two things together. It's more than just a join. It's a union. It's a superset. Tautology, I don't know what it is, but I do know that it actually exists. End of line comment, and is exactly what it says, is I go ahead and I truncate at the end, and that makes the database bark and cough up something that it shouldn't. Inline comment, and then piggyback queries. This is a valid query that's coming in, and I say, and add this thing to it and give me this other data that I shouldn't have. Give me all the list of usernames, valid for me to have, and their social security numbers, invalid for me to have, and I bolt that on and I carry that through. This is where we are today. We're in blind, or what's called inferential. So what I do is I say to you, if the username starts with A please check your database. If the username starts with A, then do all of this math. Now, if I give you a sufficiently long string of things to execute, you'll take a long time to return to me. With me? So if the username begins with A, do this calculation. Now, it's blind. And what the server says when it replies back to me is, I'm not going to tell you, versus I'm not going to tell you. It takes time. So in those blind attacks, what I will do is, and I don't have to do this me manually, I have tools that automate all of this. I will say, how long does it take you to go ahead and calculate this statement based on A, based on B, based on C? And all of a sudden, it comes back and it returns to me either really fast or really slow, depending on how I've set up my statement, the response. And now I know, I've got that the first letter of the first name does begin with D. And then I will go back and I will say, if the first letter is D and the second letter is A, do this really long calculation. And so I can go one bit at a time and I can figure out every single character by making you do math and figuring out what the time it is to respond. Now, that is called, that's called a race condition attack. It's called a timing attack. It used to be called Taktui. That's the old name for it. And those attacks, what we're supposed to do is we're supposed to say all communication from the database server is all equal time. And so we put a control in place that stops us from doing that by responding the same amount of time for each positive and negative response. We're supposed to do that, but it doesn't work. We can take and we can manipulate that in and of itself. So sometimes it's just no error message whatsoever, and that can be really slow. So I don't see what the response is. I can be handed back a generic page. Again, I can still go ahead and mess around with this because it takes a long time for you to do that SQL server to do that math on the backside. And we should generate all generic custom pages on the outside that have no meaning whatsoever to the end user, except for call the database administrator and give them this special number that only we know. And that needs to be fixed in a random way. Time intensive is really what I've talked about. And that is each new statement must be crafted for each bit recovered. So that's that whole calculate all this thing and figure out what the timing response is. That's the norm today. That's what we do. When I talk about time intensive, I'm talking about milliseconds. I'm talking about hundredths of a second. So in order for me to guess all of the particular items in a field might take me 5 minutes. And I'm not doing it because it's doing thousands of communications to that SQL server per second. And so I can just let that thing run. And I don't have to be there. I could get a sandwich. Then there's the out of band, and all I'm doing is I'm playing out of band. Now, for vendors, the general error-based SQL injection, the general error-based stuff is SQL's susceptible of pretty much everything. For MySQL, it's only susceptible to error-based and privilege-based escalation. So when I'm doing an MS SQL, when I'm doing a Microsoft SQL, I only test for these two right here. That limits the scope of my testing. For MySQL, it's susceptible to a lot. Error or union-based, you can also, in the advanced levels of this, do a web application firewall bypass. Those are called bypass errors using select statements and different number of columns. You can number the columns and talk about columns inside of the database. I don't know what the numbers of the columns are, but I can just go ahead and start, grabbing at those columns. I can bypass web application firewalls by using something and zero or null. Those are components of that. And then I can do Boolean-based, content-based blind injection. That's that a 1 bit every single time. Is this statement true or is this statement false? Time-based, is this statement true? Is this statement false? How long does it take you to return the value for you to do all that math that I told you to do? Stabilized and white space filter bypass, you put in a whole load of null characters or white spaces in there and see how it actually reacts. And then privilege escalation is nothing more than MySQL. The built-in database roles for MySQL can be abused from level to level. You're talking about user, built-in stuff like administrator, developer, backup operator, those kinds of things that are built into MySQL. Postgres is only susceptible to error-based as we know it today. There are other functions that are available to us out there that are tightly coupled with the operating system. Usually what we're talking about here is the XP command shell. In Windows, you can do the directory command through calling it through executing it through SQL Server. It will give you directory listings if it's turned on. I will tell you by default, it's turned off. And when you try to turn it on, it goes, this is really bad. You shouldn't be doing this. Somebody's going to go ahead and steal your database. And people do it anyway. Let's think database vendors here just for a second. MySQL, Postgres, MySQL, Oracle. We talked about those, but then somebody even came up with H2 that I had never heard of before. NoSQL I had heard of before, but there are all these other databases out there. So you have to be an expert in databases. Are you an expert in databases? Have you done a lot of this stuff? Do you know what those shortcuts are? From a techniques standpoint, I gave you a couple of different pieces inside of here. But the step-by-step on this, and this is where I got all of my information. So remember, I told you I'm not a database programmer and I don't play one on TV. I got all of mine from this person here who's been collecting this up for a really long time. Very talented person. I have no idea who this person is, okay? But this is that cheat sheets that gets you set up and explains how you can do each one of these. Look, they even have an Oracle injection cheat sheet that's brand new inside of there. But you can go inside of here, drill down in, go beyond the definition, detecting the vulnerability and how you actually do that, figuring out how you do bypass work, columns and ordered by. So it gives you all the details on exactly how to do that. They're all built into this one place, which is really elegant. Now, this is an arms race. So the developers are also the application, the SQL builders out there are looking for this stuff and trying to filter for it. And so we're going back and forth here. And this is always growing. Let's see. What did he say? Hasn't done much to it in the last 2 years, but it's pretty rock solid at this point. And so you have to look for the new stuff that's coming out there. From a threats standpoint, there are signature evasion techniques. I've given you the list of those signature evasion techniques that are here. You must know that they exist. You do not know how to do each one of these things. That's way beyond the scope of this exam. Okay? From a controls standpoint, I give you general ones, architectural and design ones, implementation and operation. These all fit, 4 of these fit on a note card and you key them in. It's as simple as that. That brings us back to the last thing that we're going to talk about here. I told you how to go and get all of the really good labs that are out there by Portswigger. I find that they're the best. I do give you one. We're not doing it here because we're down to the last couple of minutes. I do give you one way to go ahead and look for this in Wireshark. I'll give you one last exam question and then we're ending for the day. You have 60 seconds. Attempting an injection attack on the web server based on response to true or false is called which of the following? Okay. 5 of you got it right. This is the level of the exam. It's not any more complicated than this. I'm going to hand it back to Heidi in just 2 seconds. Email me, talk to me, turn your lab off, have a good time, pass your exam. Thank you for your focus, time, and attention. I'm going to put my email address in there, and I'm going to hand it back to the fabulous Heidi right now.
Awesome, Dean. Thank you so much. And thank you, everybody, for joining us today. Just a reminder, this class was recorded, and you can access the recording within 48 hours. Also, as you leave today, there will be a brief survey that will pop up on your screen. Please take a moment and complete this survey. It really helps us out. Thank you, everybody. Goodbye.